We're living on a disk, floating through space, with a tiny sun.
Hey, I'm FTFE and welcome back to the channel that does to stupidity what an air bubble does to a heroin addict. I'm back after my holiday and we're here with another Flat Earth debate. I hope you are prepared with some gas and marshmallows because I've got a feeling. Today, helping me out is the one, the only, the incredibly smelly Brainy Beaver. How you doing, Beaver?
Hello, hello, hello. Oh shit, I'm a vanilla.
Yes, you are.
1 second.
Oh, we can't expect Brainy to be prepared, can we? There we go.
There. And I couldn't. I was just telling FTFE for some reason my camera every once in a while does this like cold steel look that I can't seem to counter. So, anyways, yeah, I'm
That's
here
like the
in
Joss
this nice
Whedon
cool
cut of
blue
Justice
look,
League.
having a great time. Thanks for inviting me.
You're going to be moderating tonight. I use that word lightly because, you know, it's a Flat Earth debate. But thank you, because you actually contacted me and arranged this, set this up, so I do appreciate that. And let's introduce the guest for today. Well, that's the typical of you, I guess. But let's introduce the guest for today, Slave of Christ. Hello, welcome to the show.
It's a pleasure to be here.
Thank you very much for joining. So would you just, let's just get into it then, because you have evidence to present for the shape of the Earth. So we'd just like to take some time, introduce yourself, and then 10 minutes to present your evidence, and then we'd just get into the discussion. Brainy, do you want to keep an eye on the time?
Sorry, you said 10 minutes? Oh, yeah, keep an eye on
Yeah.
that. Give me a second. Just get my timer going. Okay, whenever you're ready. Sure.
Yeah, sure. So I've been studying flat Earth for about 4 years. I've been researching, preaching about it, and I don't know. I'm just gonna go right into it, right? So, if the Earth is a ball, if we use NASA's calculations, the Earth's radius should be 3,959 miles. That means if you use the Pythagorean theorem, we should be able to see the curve if you're 6 feet tall in about 3 miles, right? So this is basically disproven by the Black Swan experiment, right? So this is one oil rig is about 6 miles away. The other one is about 9.4 miles away. And this should basically, this camera is about at 1 foot observer height. These two oil rigs should be behind the curvature of the Earth. You can see the horizon directly behind it, right? My next point is that if the Earth is spinning, the atmosphere would be dragged by the spin of the Earth. This would be called the Coriolis effect, right? So basically, it would be spinning at 1,040 miles an hour at the equator. This is 10 times the speed of a 100-mile hurricane, right? So if we're in a helicopter, the Earth has to be turning under the helicopter, right? My next point is that you cannot have gas pressure next to an infinite vacuum. The atmosphere would get sucked out into space. If gravity caused air pressure, the atmosphere would get pulled down like a liquid. Since this is not how we observed gas pressure, gases expand outward, take the whole volume of the container. If gases pressure was caused by gravity, gases would have a defined volume, not an undefined volume, right? My next point is that you can't have what do you call it? A magnetic field with a molten iron and nickel core, because the inner core would be past the Curie point, right? The Curie point is basically the temperature in which the magnetic field would not exist due to how hot the core is, because the arrangement of the molecules are facing many different directions, and they would not provide a magnetic field. In order for you to create a geodynamo, you have to have a pre-existing magnetic field. This would not work on the globe because the inner core is past the Curie point, right? The next thing is if gravity was real, all the planets would crash into each other. Mass attracts mass, therefore the moon would crash into the Earth, the Earth would fall into the sun, and all the planets would crash into each other. And also, if the sun is the one that's moving, all the planets would fly out of orbit, and objects with different masses would fall at different rates, as you look at the picture right here. And also, matter cannot bend space because space is just a privation of matter, and time cannot bend because time is just an abstract concept, right? My next point is that the star trails, right? If the Earth is moving millions of miles through space, these star constellations would eventually change and the stars would eventually cross patterns. We don't observe this. Star constellations have never changed throughout history. And yes, there is no evidence that we're moving through space. Also, the sun, it's not an exploding ball of gas. It's a luminary directly above us. You can tell the sun is close because how the sun rays hit the clouds, they come down on different angles. And if you look at this picture right here, the sun rays still come down on different angles. So this is not based off the light rays hitting the clouds. This appears that the sun is directly above the clouds, not millions of miles away. Also, if you look at a sunset, the sun seems to get smaller as it moves away. The next point is that seasons don't work on the globe because you're on an elliptical orbit. This is a 3 million mile gap. As the Earth spins around the sun, it's getting 3 million miles closer to the Earth. The claim is that the tilt of the Earth is causing seasons, but the problem is that the elliptical orbit is making the whole Earth move closer to the sun. That means you cannot get alternative seasons in the north and the south. The Earth has to be getting hotter simultaneously because it's getting closer to the sun. Right. The next point is that the moon seems to be a luminary because it glows the clouds around it, and also the moon is not round because you never see the back of the moon. Also, if you watch lunar eclipses, it looks like the moon is turning red. This cannot be based off the atmosphere because when light hits the atmosphere, it scatters red. It scatters blue, not red. Shadows do not glow red. Therefore, this has to be some sort of other reason why it's glowing red. Maybe some sort of node that's passing over the moon. Also, if you take a look at the moon during the daytime, the light would be hitting the back of the moon at this angle, so this proves that the moon is self-luminous, right? My next point is that if you look at the stars seem to be look like they're moving through water. So on the flat Earth model, if you take a look, above the glass dome is water. So this may be the reason why the stars may appear to be moving through water, and the planets as well. There is no planets. They're just luminaries. I believe in the biblical model of the universe that the sun, moon, stars are luminaries, and the stars would be defined as angels, as the Bible describes, right? My next point is, hold on, let me get the next slide. Antarctica is an ice wall. It's the perimeter of the flat Earth, right? So past Antarctica would be basically the firmament, right? So we can see effects of the firmament. Like when you shine light through glass, it creates a rainbow. So on the globe model, we don't have glass. We don't have a refractive medium. And also, it's very strange that it creates a dome shape, basically what my model describes. And also, when you look down at it, it creates a circular shape, exactly what the dome is. It's circular, but when you look straight at it, it's a dome, right? Also, lightning sprites. This is electrical discharges that come off the firmament, right? I don't know exactly what the firmament is. It has glass-like properties, but it looks like these are upper atmospheric lightning. These could be coming off the dome. The pictures of Earth are Photoshop. You can tell that the clouds are Photoshop. And if you take a look at this picture right here, the 2012 image of Earth is actually way bigger than the 2013. So they do admit to photoshopping it. The ISS footage, they seem to be using green screen technology. Another thing, they use chroma key screens to float things in virtual reality. They use hairspray to keep their hair up while they're in supposed ISS. And if you take the ISS footage from different space agencies, they look completely different from the other ones that seem to be CGI. Also, they film outer space underwater. The moon landing was filmed in a studio. I mean, this is leaked footage. You can believe this or not, it's up to you. The Red Bull jump was used using a fisheye. Mars was filmed on Devon Island using a red filter. You can see little critters on Mars like this Arctic lemming, and this is actually used using Google Earth, right? So you can see the NASA symbol and Mars project of this. The Tesla car was filmed in a studio. They forgot to add the landmass of the planet behind them, and later on they had to edit the footage to add landmass. So this is how they faked it. The rockets never go into space. They go on an angle and then they go back down. And the reason why they would hide the evidence of the flat Earth is because it proves basically that we were created by God, right? So this goes into basically what the Bible describes the Earth as. You know, Genesis 1:7, God put a firmament over the waters. That's exactly what we observe. The sun and moon are circling directly above us, and so are the stars. And we're in an enclosed system, like kind of like a snow globe underwater, right? And the reason why they would lie about this is because it proves we were created by God, right? And it's all because of the Catholic Church. The Catholic Church is in control of all world governments, trying to hide the evidence of God to bring in the Antichrist. And I mean, that's basically it, guys. I don't really have any other point.
Brainy?
I know I have 2 more minutes, but you can go ahead.
Yeah, I was gonna say you have 2 more minutes if you wanted to use them, but if he's done, then yeah, then just give her.
Yep.
Yeah, that was fun.
I know. I was trying to go as quick as possible.
But you were doing good. Yeah, you were doing good. I was like, wow, he's stuffing it in there. So we got a lot to talk about.
Yep.
Yeah,
And so FTFE, yeah, there you are, buddy.
Certainly a lot of points. A lot of.
He was taking notes. See that pen? Look at that thing. That guy was taking notes. Yeah, scribble board. Good boy. Sorry, I'm just giving commentary right now.
Well, I mean, it's kind of nice to have things to take notes about, but you know, this is literally every flat Earth point that I've debunked already. So
I think what FTFE is trying to say is thank you for actually at least bringing arguments, even if there's some like the same arguments that we've heard a lot. And I don't mean that disrespectfully.
I understand. You've probably heard them before. Like I've been around the flat Earth community for a very long time, and I just collected all their points and tried to gather the best points I have. Yeah.
Okay.
I mean, hey, as long as you think you got evidence to support them, then that's what it's about, isn't it?
Yeah.
I guess we should just go through them one by one. Right. So let's start with what you said about NASA's calculations. You know, NASA aren't the ones that gave us the dimensions of the globe. They just happen to agree with the other things. So that's kind of a straw man to say that, well, NASA's measurements say, because NASA don't really give us measurements. But the black swan argument saying that, well, the Earth is this big, so how can we see this far? It's simple. Refraction exists. Refraction allows us to see further than we should be doing. I will demonstrate this with a quick video. I've got it saved here. 1 second.
Okay, so what kind of refraction?
Well, in the case of the black swan, it's a positive coefficient of refraction.
Are you talking about like a superior mirage?
Well, those are just kind of layman's terms. That's not really, if you were talking scientifically about refraction, things that you would use to describe. You would say about having a positive or a negative coefficient of refraction, talk about thermal inversions and stuff. What we are seeing in the case of the black swan is a positive coefficient of refraction. So if I could just quickly show you this video. Oh, I need to add an input. Sorry, 1 sec. So refraction bends light down. If you're going through just a plane medium, naturally it will bend the light down. Now, if there is a curve, which is what we say that there is, that means that the atmosphere above it is also going to be curved, which will mean that the light travels through more different amount of densities than if it was just straight. And that causes the light to bend down even more. In this video, you can see that this guy has this can, and he's got some plasticine on it. It's dead simple. At the bottom, you've got a stripe of yellow. In the middle, a stripe of red. At the top, a stripe of blue. And what he does is he hides it behind this curved surface of that canister, that white canister you saw there. So you've got a curved surface, which is what we say the Earth is, with something behind it being hidden by the curve of the canister. As you can see there, you can see only the blue bit of the canister. We know that there's a red and a yellow stripe there as well, but those are hidden by the curve of the canister. What he does to simulate some extra refraction is he puts a gas on it. I can't remember exactly what gas it is, but it's a gas that has an ambient temperature of 0 degrees C, which is also the average temperature over things like when you see Chicago at the other side of the lake, or in the observation of the Black Swan, that's the kind of average temperature above the water. So
can you repeat that again? What temperature is what's causing this refraction?
It's a gas that it has an ambient temperature of 0 degrees centigrade, right? So it's colder than the air around it, okay? So it's just to add a bit of extra coldness.
Okay, so inferior mirage, not inferior, my bad, misspoke.
It causes a positive coefficient. So what happens is, as he pours the gas on, well, it's actually a liquid that evaporates very quickly into a gas because it's very cold. And as soon as he pours it onto the curved surface, it increases the amount of refraction there and brings up what is hidden behind the curve. In this case, the red stripe that was below the blue stripe. This shows that refraction can bring things that are hidden by the horizon, which is an effect of the curve of the Earth, above the curve of the Earth under the right refractive conditions. I'll show you that again just so you can see it happening. As he pours the liquid on and it evaporates into the gas, increases the refractive condition and brings what is hidden behind the curve up above the curve and makes it available to see. This is what is happening in the Black Swan. Exactly the same. It is bringing what would be hidden behind the curve, i.e. those oil platforms, and bring them so that we can see them, lifting them up, because that's what refraction does on a curved surface when it's going through different densities and different temperatures. So the Black Swan is very easily explained by our model because refraction is part of our model. The Black Swan has never been an argument for flat Earth. Because if you actually look into the mechanics of how refraction works, and I've spoken quite extensively with Dr. Andrew Young, the world's leading expert on refraction, flat Earth could not make the refractive conditions that we see on Earth. For instance, a Fata Morgana, when you see the floating ships, simply could not happen if the Earth was flat because of the way we know refraction works. So that's my response to the Black Swan argument.
Okay, all right. So I have the temperature or the weather report in this specific day for this. It says the air temperature is about 60 degrees Fahrenheit and the water temperature is about 60 degrees Fahrenheit. Right. So you're claiming that its refraction is creating some sort of. I know you don't like to call it superior mirage, right?
It's creating refraction. It's simple as that. It's refraction. You always have an area above the water that is cold, and when you have just above the water, you've got an area that gets from cold to relatively warm quite quickly, and that's called having a high lapse rate, which will increase the refractive conditions. That is what we expect to happen under those conditions. It's even been modeled out by Mick West on the refraction calculator, showing exactly what would have to be happening in the atmosphere for that to happen. And it's an observation that is explained by refraction. It's simple.
Okay, so why isn't the image flipped upside down?
Why should it be?
That's what it is. Okay, so in an inferior mirage, I understand that inferior mirage can make an object look like it's dipping behind the horizon. That does happen, but a superior mirage seems to flip the object upside down.
No,
can you
not,
take a
not
look
always.
at the picture that I'm posting?
Wait, sorry. Let me bring up the your screen. Yeah. So I mean that's just standard, different types of refraction.
Yeah, I
One
agree.
one thing you're showing
Sorry,
there
go.
is a fata morgana, which again, if you look at the papers by Dr. Andrew Young, show that that is physically impossible on a flat surface for that refractive condition to happen. That can only happen if the surface is curved. But no, refraction
Can you
doesn't
elaborate?
always flip.
Sorry.
The mechanics of refraction, the way that light is bent by a medium as it passes through different densities, simply, if you do the maths, it simply doesn't comport to a flat Earth, especially with observations like a Fata Morgana. You would have to rewrite the mechanics of refraction to explain that observation on a flat Earth. However, the observations that you are showing, like seeing this right now, are perfectly possible if the Earth is curved under pretty standard refractive conditions.
Okay,
All you need
so
is a little bit of a thermal inversion there. And we know
okay,
that what we are seeing there isn't completely correct because, cranes don't bend like that. So we know that there is refraction happening there. Well, of course there is. We're
okay.
looking for a medium. There is always
So
refraction.
the claim is that the two cranes, they're actually behind the curve, but the reason why you can see again is because of a superior mirage, right? That's the claim?
Because of refraction, yes.
Okay, so like I said, in a superior mirage, inferior mirage dips the object behind the horizon. Superior mirage makes puts the object higher but flips it upside down,
No, it
right?
doesn't
So
always flip it
why
upside
is
down. It
I'm
does
sorry,
not
what?
always flip. It does not always flip it upside down. That's a special type of mirage, a special type of refraction. No, superior mirages, inferior
Can I?
mirages do not
Sorry.
always
Can I have a
flip the
video?
optic
Do you have a
upside down.
video of it of an object, like a superior mirage happening, like a video of it
I showed you
not flipping the object upside down?
I showed you the superior mirage happening with the video that I showed, bringing it up above the horizon. It didn't
Okay.
flip that upside down.
Okay,
Because
fair enough.
that is actually not the standard thing to happen. And, it flipping upside down is when it encounters a thermal inversion. That's the only time that you can get that to happen. Again,
Okay,
I'd encourage you to look up the works of Dr. Andrew Young, the world's leading expert on refraction. In fact, he is more than happy to answer emails personally and talk you through refraction because he has studied refraction his whole life. And he's actually dedicated quite a lot of work to explaining how what we see with the observations we see are completely impossible if the Earth is flat. So it's very simple. Black swan is explained by refraction, and that's the answer to it.
So there's one more thing. So I have the weather report right here, and it says that the air temperature is 60 degrees Fahrenheit, and then the water temperature is about 60 degrees Fahrenheit. So it's about 3-degree difference. Why would that create a superior mirage that would raise the image? I mean, let me think. I have to get the curvature formula real quick. One sec.
Because it's not just about the temperature at one specific point. It's about the lapse rate. It's about the change in temperature over distance.
Gotcha. All right. So it should be raising the image about.
Let me get it up. That's what she said.
You don't have to pull it up. I'm just looking at it myself.
Refraction.
It should be raising the image about 60 feet. So why would a 3-degree difference raise the image 60 feet in order for us to be able to see the horizon behind it? That's my question.
Again, it's over a further distance, and so that how far away is the furthest oil rig there? 9.4 miles, right?
9.4 miles.
Right. So that means that for that to be visible, it has to bend light 0.08%. No, 0.8%. No, sorry, 0.4%. No, even less than that, 0.2%. It has to bend light 0.2% of a degree to be able to see that far. 1 degree on Earth is 69 miles. So to see 9.6 miles, light only has to bend 0.2 degrees. Standard refraction is about 1 degree. So that's below even standard refractive conditions.
So a 3-degree difference will create a superior mirage then?
Yeah, as long as if there's a difference between the the temperature just above the surface of the water, and then going up, say over the 5 feet above the water, right? If the temperature changes between that, it will cause like extra refractive conditions. And the more the change of temperature, the higher the lapse rate, the more intense the refractive conditions will be. I just wanted to bring up this.
Sure. I mean, I don't want to go in circles, but yeah, that's fine.
The audience is definitely wanting us to move a little bit, but
I mean, I get what you guys are saying.
It's definitely not. It's definitely not much different than the reflection off of a highway. You know, when you look down a highway.
Okay, let's. So I did bring up a lot of points on you guys, so I think I don't mind moving from point to point. You know,
one thing. So if we right, here we go. So this is the oil rigs that we're looking at, and this is the refraction simulator that based on the maths of refraction as we understand it. And you can actually go in and change the presets as to if it's a flat earth or right. So this is what we see with the black swan, and it actually shows you here what you would have to have happen with the atmosphere, the change in temperature, for you to be able to see that. So all you need is the change in temperature, you know, from there to there. It's only a few degrees to actually get this change. So if the atmosphere is doing this as you go up above, then this is what you expect to see. We can even model it because we understand it so well.
Can we put the exact measurements that I had on the?
This is the exact measurements. This is an exact replication of the black swan image.
Okay.
And
so is
you can even go to it and say if you set it up to say a clear day, which would, you know, normally you kind of see it behind, but then if you just like start playing with, you can see that only a slight change in atmosphere, a slight change in temperature starts bringing it up above.
Can we do 60 degrees and then 63 degrees, see what that would look like?
I didn't realize that Mick West made a calculator out of it. He's badass.
Yeah, I don't know how to change the temperature on this. There might be a way.
Okay, because in order for us to model it, it would be 60 and then put 63.
Yeah, so he's actually got that here. So that's the
well, I was going to say there's no need to change because it's based on ocean temperature and then that scale right there, right?
Yeah, I understand. But the idea is that the temperature below the air above it should be lower, and that's what would create the raising of the image.
Yeah,
due to refraction.
As it's showing here, you've got like a pretty low temperature just above the water. Then the further up you go, the temperature gets hotter.
Well, what would it look like if we put it at 60 degrees? Is that what you did?
Yeah. Well, this is roughly. I think here is about 60 degrees Celsius. So that's kind of right in the middle. So just like a few feet above the water is 60 degrees Celsius. That's what this is based on. Because he's actually
got temperature
based on the temperatures.
What's he using as a scale there? What, like those numbers 7, 8, 9, 10, 11? Like, is that plus? Is that above?
I think that's Celsius
ocean temperature though.
I think this is just the actual temperature in Celsius, and this is the height above the water in feet.
So that would make sense.
The further up you go, the warmer it gets.
Right, Celsius.
Right. And then
I live beside America. I'm always having a Fahrenheit everything.
I would encourage you to have a play around with that refraction simulator yourself.
Yeah, no, I'm just teasing. I'm HVAC, so I have to Fahrenheit most of my days. So sometimes I forget to go back.
So if you have a play about with that refraction simulator yourself,
can you pull it back up? I just want to see it real quick.
Yep. Sorry, where did it go? So if you set it to the this is exactly what we see.
Temperature in Celsius. So I have about here. I just want to see what it would look like. I got 15.8 degrees Celsius of the water and then 17.2 degrees Celsius. I understand that the water obviously is not the air, but it should be similar because if the air temperature
at the water temperature. I see. Right.
I'm sorry. What you say?
There's no.
Yeah, this is the temperature of the air. It's not the temperature of the water that makes the difference. It's the temperature of the
I understand
air.
that, but it would make sense that the temperature near the water should be kind of similar at the temperature above, like the air at the bottom.
Well, but that's what makes the effect happen, right?
Yeah,
actually, the fact that they aren't.
what you find is that the air just above the water is usually colder than the water itself, due to the fact that it moves along, and I can as a
well, an
sailor, I can
evaporative
testify
effect
to that.
actually sucks heat away. So as water evaporates, it tends to actually suck energy. At least I believe that would create an effect. But
what we have here is this is based on the data from the black swan photo. So
can you put it at 15?
That's what this is.
I just want to see what it looks like. Put it at 15.
That's what this is.
Like
so
the very bottom one.
If you look at the bottom, you've got the the air temperature at sea level at about 8 degrees centigrade, and then I'd say 50 feet above the water, it would be about 15, 16 degrees.
I have about so I have 17.2 degrees Celsius, and then I have 15.8 degrees Celsius. That's the difference, the water temperature. Because the thing is, obviously, like, the people that did this experiment didn't test, like, the levels of, like, the heat based off the height.
Yeah, it's just a picture, and the guy that took it said that, this is like a really rare thing to get. But please have a play around with the refraction simulator yourself, because it really does help.
Okay.
And let's move on to the next point that you brought up, which was spinning Earth. And
the Coriolis.
I was slightly confused because
can we actually hold on before we do that? Can we actually go to the air pressure, the gas pressure argument that I used?
Yeah, that was the next one.
Okay, fine. Which one do you want to do?
Let's do the spinning Earth first, because...
Sure, okay.
Could you... when you said Coriolis, I don't think you actually described Coriolis. What do you understand Coriolis to be?
Okay, so what I understand Coriolis is, as the Earth spins, since the atmosphere is, it's being pulled in by gravity, but there's nothing causing it to move with the Earth, it would be dragged by the spin of the Earth. Yeah,
that's not Coriolis.
Okay, then what is it?
Well, Coriolis is about conservation of momentum and is to do with a change in vector based on conservation of momentum. So, for instance, if you were at the equator, which has a tangential velocity with the rotation of the Earth of 1,012 miles an hour, and you fired a ballistic projectile north, right, that ballistic projectile would maintain the momentum of the 1,012 miles an hour as it moves north into an area of the Earth with a lower tangential velocity. So as you travel north, you're no longer traveling, tangentially at 1,012 miles an hour. You're traveling, say, at 800 miles an hour. So the ballistic missile would maintain its momentum of 1,012 miles an hour whilst moving into an area of the Earth moving at 800 miles an hour. Therefore, it would be moving 200 miles an hour faster than the Earth, and it would drift ahead of the rotation of the Earth. It's got nothing to do with the atmosphere spinning with the Earth. That's a complete straw man of what Coriolis actually is.
Okay. But so my question is, should that happen on your model? Is the Earth turning under, like, objects? Like, if I have a helicopter, should the Earth turn under that?
No, because the atmosphere does rotate with the Earth because of friction and gravity. On one side you've got the Earth rotating, which is dragging the Earth with it. On the other side, there's the vacuum of space, so there's no friction. So the atmosphere rotates with the Earth, and the helicopter uses the atmosphere to maintain lift, and therefore would rotate with the Earth if the atmosphere is also rotating with the Earth.
Okay, so would that mean that if I were to go up higher, that the atmosphere would have to increase velocity in order to keep momentum with the Earth?
No, it still maintains its 15-degree rotation.
What would cause the atmosphere to move to increase in velocity at the higher levels?
It doesn't. It has a faster tangential velocity because again of drag and gravity, and it's all pulling it round. The same as if you were to put a bit of ink into a bucket of water, right? And you were to spin just in the middle, right? And keep spinning and keep spinning and keep spinning. Eventually, the water at the edge with the ink in would be spinning at the same speed as the rest of it after a while of spinning. After you've overcome the friction at the edge. That's because the drag is transferred through the column of air and pulling it with it. Gravity pulls it towards the Earth. the drag pulls it around with it, and the whole thing rotates at 15 degrees. As you go further up, there is actually a very, 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 very slight decrease in the relative angular velocity, but only very, very slight. But for most, for practical purposes, the entire atmosphere rotates with the Earth. What you described as Coriolis isn't Coriolis. You're using Nathan Thompson's version of Coriolis there, which just isn't what Coriolis is.
So my question to you is, I understand what you're saying. You're saying that it would be dragged, but I still don't understand. If the atmosphere is truly moving with the Earth, then if the farther you go out, since we're on a sphere, the atmosphere would have to travel a farther distance and move faster than the bottom portion. So what would be causing this, the atmosphere to move faster at the outer portion?
Drag, like I just explained to you. If you spin the water in a bucket, just spin in the middle, eventually, after a while of spinning, all of the water in that bucket, not just the bit at the center, will be spinning the same speed, because that energy is transferred outwards with the angular velocity.
But it has to travel a farther distance in the outer portion.
Yeah, same as in a bucket. Explain, my explanation of the bucket, right? Why is the outside of the water spinning just as fast as the inside of the water? What's causing that?
Sorry, repeat that. I didn't hear it.
So, right, take a bucket of water and just in the middle, just spin the water, right? After a while, all of the water in that bucket will be spinning the same angular velocity as just the middle bit that you are spinning, right? So what's causing the water at the edge of the bucket to travel just as fast as the water in the middle of the bucket, even though that's got further to travel? It's the same physics.
Okay, so do you have? I don't think I've seen this before. Do you have an example of the water in a bucket spinning faster than the middle?
Well, no, it spins the same speed. It spins at the same angular velocity. It doesn't spin faster.
You're not saying that it would not move at the same. You're not saying it would be dragged. It would spin slower. You're saying it would be moving exactly at the same, like a wheel. Let's say I'm spinning a wheel.
Yes.
The outer portion would have to move at the same exact rate as the middle.
Yes.
Even though the outer portion has to travel a farther distance.
Yeah, that's exactly what happens when you rotate water. The whole thing starts to rotate at the same speed, not just and then imagine if there was no bucket or a hydrophobic layer with completely zero friction. That water is going to have the same angular velocity because each water molecule is touching the next one and dragging it along. So it's dragging it round each time. So the angular velocity stays the same for the entire thing. That's what happens with fluid dynamics. It's a transfer of energy from one molecule to the next. And over time, millions and billions of years of Earth and the atmosphere being there, and friction on one side but not the other, and gravity, the entire atmosphere moves the same angular velocity as Earth. But that's the answer to, what you described as Coriolis is not Coriolis. And the atmosphere rotates with the Earth because of friction and gravity.
So, okay, that's fine. But what about when Neil deGrasse Tyson says that the Earth spins under field goals? Do you agree with that?
He did not say the Earth spins under field goal. That's a complete misquote of what he said. His exact words were, due to the winning field goal was likely aided by a 1/8 of an inch deflection to the right, aided by the Earth's rotation. Those were his words. He never said the Earth rotates under a field goal. He was describing a Coriolis effect because it's the Earth rotating that creates the Coriolis effect, because that ball had to go from one area of linear velocity into another area of linear velocity and drift accordingly. He never ever said that the field goal rotated underneath the Earth. That is a flat Earth misrepresentation and misquoting.
Okay, that's fine. Do you want to move to the next point then?
Yeah, gas pressure next to a vacuum. So,
cool.
Do you want to elaborate on your point here?
Yeah, so basically my point is that, okay, so if gravity was creating a gas pressure, the gases would fall down to the earth like a liquid, right? Gases would have a defined volume, but since we don't observe that, gases have an undefined volume. They expand outward and take the whole volume of the container, right? So that's my disagreement. Since we observe gases to act differently, then
not always though. Gas doesn't
then
always
this model
do
would be
that.
false. In order to have gas pressure, you need a container. That's basically it.
I mean, well, there is a container. First off, the universe is a lovely container. It contains all the pressure in the universe. But there simply is not gas pressure next to a vacuum. All right, that is a straw man of the position we hold. All there is there's a gradient from 14.7 psi up to practically zero. And we know that gradient exists. You know, it's been measured. You can go to the top of Mount Everest where the gas pressure is like 10 psi lower than the base of Mount Everest. There's no barrier or container between those, and the pressure just keeps dropping the further up you get. That's all we claim, because we know that's a fact. It's been measured. There is a gas pressure gradient.
Yeah, I agree with the gradient, but what I believe the gradient is caused by temperature variation, right? So if there's higher, if like at the top of the mountain, it's colder. That's why the air is thinner. That's why air gets thin when it's cold, because the air is moving around less, right? But as it gets hotter,
doesn't get thin
the
when
air
it
is
gets
moving
cold.
around faster.
Those are not dependent on each other. As somebody who does refrigeration as my career, commercial industrial refrigeration, that is not like required though. Like you can have like you're right in some ways, but that law also only counts like that with pure elements as well. When you start mixing gases, they don't have the same kind of direct relationship and stuff. So there's a lot more in there than just, you know, temperature of object go down, pressure go down. That is true, but it's not going to create, you know, as you said, you know, you want to fill an empty space. So at what point does temperature overwhelm your pressure in a container theory?
At what point does Sorry, go ahead.
Well, you're saying as the temperature drops, the pressure will drop, basically. But at what point does that? So, but the thing is, we know that at certain points up higher, it also gets hotter because there's layers up there that are warmer, the patches. So why is the pressure still dropping those warm patches? It's not a linear relationship.
Also, you've got to take into account that the air pressure at, say, Hawaii at sea level is 14.7 psi. But the air pressure at Antarctica at sea level is 14 psi.
0.696, get it right. You got the math wrong at school.
But there's a, you know, a 30, 40, 50 degree centigrade difference, yet the pressure is exactly the same. So your claim that the gradient is caused simply by temperature doesn't make sense, because temperature doesn't always equal lower pressure or higher pressure.
Okay, so you're saying in Antarctica it's not the case?
No, you know, the temperature at sea level is pretty much the same all around the world. Yeah, you get fluctuations based on weather and stuff, but generally the air pressure at sea level at every point on Earth is around 14.7 psi.
It's literally what we based it off of, based on the composition of the makeup of the, you know, of the gases of our environment, which are 76 or something percent nitrogen, 21% oxygen, 3% like argons, and there's a bunch of extra exotics in there that make up the extra percentages. But basically, yeah, based on that mixture, that's air that we breathe on Earth. That is exactly what the pressure will be at sea level. I mean, you know, based on like he said, it might vary by a decimal just based on the local temperature, because you're not entirely wrong about pressures and temperatures, but we're not talking about something that can cause it to drop to zero. Like, that's just absurd, because then why wouldn't the pressure come pour in? Temperature will not stop a container from filling up with fucking air.
No.
Yeah. Okay.
Like,
so I wanna kind of create like a little hypothetical, right? So if I like say I have like two chambers, right? Like if you look at the picture I have these two chambers. If I cut the air pressure in half, right? Will the existing gases fall to the bottom of the container, or will they expand outward and equalize throughout the container?
It depends on the amount of kinetic energy they have. Once the kinetic energy is expanded, is over with, it goes down. Yeah, it's as simple as that. You know, gas
So
doesn't
it will
always expand.
Sorry.
You know, on Earth, gas doesn't always expand to fill a space. There is plenty of gases that are heavy and dense enough that you can open a container and the gas will not escape.
Oh, I'm talking about like gases with the same density. Like, let's say I have only oxygen inside the container. If I cut the air pressure in half, will the existing gases fall to the bottom and there will be a vacuum directly above it? Or will they expand and take the volume of the container?
Well, no, it would create a gradient inside. There's always going to be a gradient inside that container.
Okay.
Because even inside containers on Earth, there is still gradients in the pressure. You know, you take a canister of oxygen, and the bottom of that canister will have a higher pressure than the top of that canister. But then if you flip that canister over, it changes. The pressure switches. So
would you say that gases have a defined volume then?
No. You know,
like a liquid?
Gas, doesn't necessarily have a defined volume. But it also does.
You can compress a gas, not a liquid,
Yeah.
though. That's going to be a big defining factor.
Sure, but like ultimately, gases have an undefined volume, right?
Your volume is going to be determined by it's going to be determined by the surrounding pressure around it.
Yeah.
Because if it's got no pressure around it, you're right, it will expand outwards unless there's another force acting on it.
Yeah.
So
when there is
weight
no
of itself.
When there is no forces, gas will expand constantly. Because there's the kinetic energy will make it start moving, and once that kinetic energy is over with, it will just keep moving. An object in motion will stay in motion. But if there's
that's
another
actually
force
why I was going to add. That's actually why the second stage of rockets. Well, I know you're not big on that, believing in that, but if you wanted to, the second stage rocket engine has got a much larger cone, like a very big cone on it. And it's because when the gases come out and they're actually up into no atmosphere already, or very, very minimal, like molecules of it.
Yeah.
That gas wants to rapidly expand, and by having a bigger cone, they're able to get a better efficiency out of the engine because it expands faster than in the atmosphere.
But the biggest point that I'm trying to make is take a container, all right, and fill it with whatever you want. On Earth, fill a container. The bottom of that container will have a higher pressure than the top of that container. But take that container and then flip it upside down, and the higher pressure is again at the bottom, even though it used to be where the top now is, showing that there is a force making the gas pool at the bottom, with the rest of it sitting on top, creating a gradient as there's less and less gravitational acceleration acting the further that you go up.
So kind of like a liquid, right? Like how a liquid has like a gradient, right? At the very bottom
fluids,
of the...
fluids have all fluids will have a gradient. Not
just
just liquids,
like a liquid.
Not just gases. Well, a liquid is a type of fluid. So we need to we need to talk in fluids, because the atmosphere is a fluid. Oxygen can be a fluid.
But I don't think
Liquid is a fluid, right? So we can talk in terms of fluid, and any fluid on Earth will have a gradient of pressure, higher at the bottom, less at the top. And there has to be something causing that, because it doesn't matter what the temperature is, that gradient will still exist, always. Even in the room that you are sitting in right now, there is higher pressure at your feet than there is at your head.
Okay. Do you guys want to move to the next point?
Yeah. Just to reiterate, we don't say there's gas pressure next to a vacuum. There's simply a gradient. There has to be a force causing that gradient because temperature is irrelevant. The next thing you brought up was a magnetic field and the Curie point. I assume you're talking about the fact that the Earth has a magnetic field, and you don't think that it can be created because the molten metal core is too hot, therefore past the Curie point. Is that correct?
Yeah. Do you want me to re-elaborate on my point?
Well,
I was going to say, I don't know anything about what the Curie point is, so I'm ready for a good listen here.
Sure.
Right,
so the idea is that, so the Earth is actually a geodynamo, right? So are you guys familiar with the dynamo effect is?
Yes, yep.
Okay, so I'll just explain for the audience. So what the dynamo effect is, it's like an electromagnet. As it moves, so think about like a copper coil, right? As a magnet moves through a copper coil, it creates electricity, right? So the idea is that the Earth's inner core has an existing magnetic field, and the outer core is spinning around the inner core, and it's generating electricity, and it's generating in a larger magnetic field, right? So the problem that I have is that it's claiming that the inner core has the pre-existing magnetic field, right? But the problem is,
No.
if you look at the temperature of the inner core, it's past the Curie point, right? And if when you heat up a magnet, it stops working because the poles of the molecules are facing many different directions, right? And that's the problem with it. And not only that, if we use the equation, I understand if you increase the pressure inside of the inner core, it's going to increase the Curie point. But if you actually do the equation and check, like I think the inner core is about 300 or 3,300,000 gigapascals, it only increases the Curie point about 140 degrees. Right. So
Okay.
my claim is that you can't have a pre-existing magnetic field to create a geodynamo with the what do you call it?
Yeah.
With the inner core. But go ahead.
So there is no pre-existing magnetic field, and the magnetic field is not caused by the inner core. The magnetic field that we have is nothing to do with the rotating iron core that we have. It is actually caused by convection currents in the outer core. The simple movement of things rubbing against each other, and that is how the magnetic field is created. It's nothing to do with the rotating iron core. The Curie point doesn't come into effect because it's nothing to do with generating a magnetic field in that way. It's simply caused by convection currents in the outer core. The problem is that flat earthers don't understand how the magnetic field of Earth is actually created.
I want Professor Phil Bell saying nonsense. Which Phil told him that in big capitals? He's very angry, it looks like.
Yeah.
Well, I want to, can you tell me what exactly is generating the magnetic field in the outer core? Like, you said the convection currents, but what about the convection currents will generate electricity?
Simple movement, friction, static charge, constant movement of all that stuff moving around, rubbing against each other.
And that'll do it.
Go and rub your head against a balloon or scrape your feet when you got socks on across the carpet. You're going to build up charge, and there's enough movement in the convection currents of the outer core that it creates enough for a magnetic field to be caused.
Okay.
Are
you familiar?
It really is nothing to do with the Curie point. Flat earthers found a term and misapplied it to the actual model of the Earth.
Can I just ask what the northern lights are and the southern lights? Like what those are to people
I don't know
that
exactly.
don't think we have a magnetic. Oh, okay.
I'm not entirely
because
sure.
we can measure the magnetic effects coming off of it. They fuck with like satellites, and they make it so that like our phones don't sometimes work, and they could even be so powerful sometimes. Like what was it, the what's it called, the whatever event, where that was an electromagnetic storm where it lit up all the telegraph lines. The Carrington event, where it basically electrocuted all the people running all the telegraph lines and stuff like that. Beep, 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 beep. They're all getting electrocuted all around the world, and because of course all that electricity just came pouring out of the atmosphere one day.
Okay, so are you familiar with this experiment? They took, I think it was a man named Daniel Lathrop. He took I think he took molten sodium, and he tried the same exact idea, right? So, and he was mixing the sodium, and he couldn't generate a magnetic field other than when he was providing electricity on the outer portion. Have you seen this before?
No,
you guys probably have.
That's kind of not analogous to the Earth because, you get a lot of free electrons from the fact that there's a rotating iron core and everything, and the static charge that is built up because of the convection currents in the outer core isn't really comparable to having some molten sodium. It's not on the same scale. It's not with the same forces. That wouldn't be how it would be made. The amount of heat and pressure that is in the Earth causes convection currents and constant movement, which creates the magnetic field. which then
Yeah, but hold on.
solar energy
from what
and
I'm
stuff.
Sorry, go ahead. My bad.
Sorry, go on, Brainy.
I was going to say, from what I'm reading, they did generate a magnetic field, and they even found that, as we suspected for a long time, that the Earth's magnetic field flips every 500,000 years or 250,000 years. It even showed that their magnetic field began to flip. It says Nicholas Mordaunt and colleagues. Is that who you're talking about?
I think his name was Daniel Lathrop.
Okay, well, so these people from École Normale, whatever the hell, Paris and other French institutions, however, have witnessed one of the peculiar effects of dynamo action for the first time. The team heated 160 liters of molten sodium to over 110 Celsius in a chamber, keeping the metal in high turbulent motion using 2 counter-rotating propellers. They then monitored the size and direction of the magnetic field and noticed a strange effect when they happened to set the speed of one of the propellers to 16 hertz and the other to 22 hertz. The magnetic field of the entire sample began to flip direction at irregular intervals ranging from 10 seconds to 180 seconds. So the article goes on to say that it seemed to mimic the magnetic reversal that they believe, based on fossil evidence, that Earth goes through.
Okay.
So, I mean, unless they're lying, they apparently were able to generate a magnetic field with molten sodium.
Well, so he was able to generate a magnetic field in this. Actually, can I send you the video? And like, obviously, I could be completely lying to you, but like you could hear what he says. You know what I mean?
Yeah.
How do I send the video to you? I don't really use Zoom.
I mean, are you able to just play it from your side?
It's literally just a minute long. It's not like an hour.
You could send it to my email.
Okay.
Flerfs@gmail.com, or
I can't. There's no chat in the Zoom call.
There is a chat in Zoom call. You might be able to.
Oh, I see. Okay.
Is it on
Of course, this person also goes on to mention that, like, as a good scientist would, saying, however, they warn that their observations should not necessarily be used to draw insights into large-scale systems. So that's the other problem, too, when we're trying to do small-scale versus large-scale. There are often times where we think that we take something this big and we just scale it up this big and it'll work the same. And when we do it, everything about how we understand it changes. So, there's that, too.
Sure. Okay. I mean, we can move to the next part, or we can watch like the.
We can come back to the video another time if you like, but
I have the video right here. I mean, I'll just send it to you.
They're starting to use. You know what's something crazy? They're starting to use molten sodium to cool nuclear reactors now, so that they can run them in places in deserts where they actually don't have. They don't have water access, so that way they can actually just have gigantic vats of molten fucking sodium, and then they use the molten sodium to cool everything off. And I guess the problem in the past has been not having materials that were good enough to hold molten sodium. And now we're getting to the point where we're making new alloys and stuff like that can actually hold things as hot as molten sodium. So it's pretty cool.
All right, here. It's called... I mean, you guys can look this up on your own. I have the video right here. It's called "Spinning Sphere of Molten Sodium," and he just kind of describes. I'll put it in the chat for you guys. I'm sure you guys have seen this before. Go ahead.
I'll put that in the description so everyone can see it themselves.
We can move on from this. They can watch it.
Gravity should make the planets crash into each other.
Okay. All right. Let's go to that.
Do you want to explain why you think that's the case?
Okay, so basically, I think you hold to the, I think it's the Einsteinian theory of gravity that gravity creates a dip in the space-time, right? So that would a dip in the fabric of space-time. So ultimately, the planets would just fall into each other over time, right?
Well, why would they fall into each other over time?
Just like this picture that I'm holdling up right here. Right. If there's a dip in the gravitational field. Sorry, God.
Right. So you mean like of the marbles, right? Going into the middle.
Well,
right?
do they not actually fall into each other over time? But it's going to take a goddamn long time, isn't it? Excuse language for you, but yeah, you know what I mean. Well, it's going to take a long time, isn't it? Their FTFE, isn't that the idea? Like the moon will eventually fall to Earth.
Actually,
it's
the moon's
just
moving
not
away.
Not in a time frame that we're going to care about.
Actually, the moon's moving away from Earth because basically.
Oh, is it?
What's happening what's happening on that rubber sheet is the energy is being lost due to friction, right? So you start spinning the marble around, right? And not only is it being, it's going around on the sheet, which is causing friction, which is losing energy. So it loses its speed. But if there was nothing to take away that velocity, which in space there isn't. There's no friction. There's no reason why that thing that's moving would ever stop moving. And once it's moving fast enough to miss the thing that it's orbiting around, which is what happens, that there's no reason it should ever stop, because there's no friction in space like there is on that rubber sheet. So the best way that I can think to describe this is, imagine taking a ball and you throw the ball forward, right? What happens to that ball? Does it causes an arc, right? It goes forward and then falls down in an arc. Now, imagine if you were able to throw that ball hard enough that the arc of the curve of that ball matched the arc of the curve of the Earth, right? And then it would just keep falling around the Earth. Obviously, the atmosphere is going to make it slow down, but take away the atmosphere, and then it's just going to keep falling around. There's no reason why it would come closer, because it's in free fall, but it's going fast enough in a tangential velocity that it misses the thing that it's falling towards.
Okay,
and then just keeps falling around.
The only thing I want to add is apparently the moon right now, okay, so real numbers, the moon is moving away from us at an average, because we bounce a laser off of it. That's how we know that. But it's moving away at 3.8 centimeters per year. But they said, but what's fun about that is it's going to create an elliptical that will actually put it into an inward spiral, a catastrophic inward spiral in 65 billion years. Because it's going to change the orbit to a point where eventually it becomes like an elliptical, right? And then it starts.
I'm all right then. I've got a fair few years, but yeah.
Yeah, we're gonna be okay, and that's what I meant by not in our freaking lifetime, though. Like not in our kid. This planet won't even exist based on our understanding of the universe, because the sun will expand and take it in.
Do you think it should be moving closer though, like continually, due to the gravity?
No,
well, but you don't understand orbit then.
Yeah,
but that's the thing. That's where orbit comes in.
Yeah, the moon is falling towards the Earth, all right? The moon is in free fall towards the Earth, but it's moving fast enough, tangentially to miss the Earth. And because there's nothing to ever stop it, to slow it down from that tangential speed, it's just going to keep missing the Earth.
Like if you imagine yourself jumping over a beach ball on your floor, and you run and you jump over the beach ball, well, you fully expect. It's a bit of a shitty example, but imagine you're in the air and you jump over that beach ball, and the beach ball just you're supposed to fall to the beach ball. The beach ball is the point you're going to fall to, but as you move forward, if you're going forward fast enough, will you hit the beach ball or will you swing around the beach ball? So like all that's happening in an orbit is you're just constantly falling as you move forward, because it's a sphere. As you move forward, the object falls away from you, and you move forward more and it keeps falling away, and it just falls away and falls away. So all you're doing is falling constantly in a circle. It's really kind of, I get it, it's counterintuitive, but you're really just kind of constantly falling inwards. But the planet's a circle, so you just never, and that's what orbit is. Orbit is that perfect point where you're going at the right speed to not throw away from it, but just fast enough that you're going fast enough that it's constantly falling away from you at a rate where you're never gonna literally hit it, because it's never there.
Okay, do you mind if I ask okay, so this is kind of like a different question, but it's similar.
Yeah, go ahead.
So like, let's say there's a dip. Okay, so the Earth's creating a dip in the gravitational field. And the moon is circling around it, right? So the Earth is also moving around the sun. So why wouldn't the moon just fly out of orbit if this is the case?
Well, right, you have to think of that. Look at your graphic and the dip of everything, right?
The bottom one, this one right here.
Yeah. Now, the Earth and the moon are classed as one system, right? So the Earth and the moon are creating a warp in space-time, a gravitational well, right? And that gravitational well of the Earth-Moon system is orbiting the gravitational well of our sun. So
the top right example is honestly the best one he has there.
Yeah.
Because it's just take away the friction, and imagine that blanket doesn't exist though at the same time, and they're not actually touching anything.
Like, I'll give you an example. Like, what I think what should happen, right? Like, okay, so we have the object in the very middle of the sheet. Okay, the objects are spinning around it, but also the object in the middle is also moving. So as the object moves, why wouldn't either one of the balls fly out of orbit or just crash into the middle? Like, that's my question.
Because they're all moving within their own gravitational reference frame. So, if you then take the entire solar system, that is one gravitational body, which is moving around the center of our galaxy. All right. But then within that gravitational system, you have your own gravitational systems. But the whole thing is classed as one. So the Earth-Moon system is orbiting around, the gravity well that the Earth-Moon system creates is orbiting around the gravitational well of the sun. But the entire solar system creates its own gravitational well that is moving around the center of the galaxy with, the rest of the stars. Which actually answers one of your next questions about star trails and the fact that, things.
Oh, I had one last question about this, and then we can move on to the star trails. Is that okay?
Yeah.
Okay, so my question is, so the idea with gravity is like, do you agree that objects with higher mass have a higher gravitational attraction, right?
Well, gravity is dependent on two things, all right? Fg equals g m1 m2 over r squared. That means that the gravitational force is proportional to the mass of the two objects, but inversely proportional to the distance between their centers. So the gravitational acceleration of anything really depends on two objects and how much they are attracting each other based on both their mass and the distance away from them. But the thing with more mass will create a larger acceleration than the thing with small mass.
Oh, cool. All right. So do you see the picture that I have at the bottom left, this one right here? So do you agree that the feathers or the ball would have a higher gravitational attraction than the feathers?
No, well, both of those objects are being attracted to the Earth, right? The force of acceleration between them, the acceleration is the same, but the force created is greater, i.e., if you put a scale on the bottom of those, the apple would weigh more when it's on the ground because there is a greater force, right? The force, the weight, is a product of both the mass of the object and the acceleration due to gravity. The acceleration due to gravity is the same on both of those objects, roughly 9.8 meters per second squared, all right? However, the force is greater on the apple, which is why it would weigh more and hit with more impact, even though they would both fall at the same speed in the vacuum because the gravitational acceleration is the same.
But wouldn't the gravitational acceleration be higher with the objects with higher mass?
No, there's a higher force between them, okay? The acceleration, right, you have to take into account that both of those objects, the feather and the apple, are actually on a very, very tiny scale moving the Earth towards them as well, all right? But the acceleration that they create because of their mass is so tiny that it's insignificant compared to the acceleration that the Earth makes, which means that they will both have the same gravitational acceleration that the Earth generates acting on them at the same time, approximately 9.8 meters per second squared. But because there's a difference in mass, the apple would hit the ground with more force than the feather and would weigh more. So that's what happens. Because it's got more mass, even though it has the same gravitational acceleration acting on it, there is a greater force because there's more mass.
So that was, I'm guessing that's a yes, right? There would be a change in acceleration. You're just saying it's insignificant because it's not big enough, I guess?
Yeah. Those things compared to the Earth are so tiny that their gravitational acceleration that they are pulling the Earth towards them with is, practically immeasurable. We know it exists because of all the experiments that we've done on gravity, but, gravity is a product of the mass and distance between them, and the Earth has such a bigger mass than those objects that, the gravitational acceleration from one is going to be infinitely higher than the gravitational acceleration of the others. So you won't notice that much, pretty much any difference. But what you do notice, like I said, is a difference in the force, which is why the apple would hurt if that hit you on the head, but the feather wouldn't.
Okay. Do you want to move to the next point then?
Yeah. So, well, the next one you came up that you said was time and space can't bend. Eddington's experiment in 1919 would very much disagree with you.
Okay.
Do you know what that is?
No. Elaborate.
So during a solar eclipse, they were able to see the stars behind the sun, right? And they knew the position of the stars. But they were able to use the solar eclipse, the eclipse, and look at the position of the stars and see that the stars that were apparently close to the sun changed position, because light is affected by gravity, because mass creates a warp in space-time that even light has to travel through. So this showed that the mass of the sun was warping space enough to change the position of the light that was coming near the sun. And this has also been replicated many times in other eclipses, but that was the first time that they had a hypothesis about what was going on, and the best way to test it was to do an observation during an eclipse. The eclipse allowed them to see the stars that were close to the sun, and the position of the stars changed the amount that they predicted it should based on the mass of the sun. So yes, we know that space can absolutely change because, of mass, and we also know that time can be changed based on speed and mass. This has been evidenced by GPS satellites, for instance, that travel so fast that they actually don't operate on the same time frame as us. And there has to be many algorithms in place to actually calculate the difference.
Time dilation.
They calculate the difference in the time dilation from the satellites that are orbiting the Earth really fast compared to us, so that we get the correct data. It's the old twin paradox. If you take two twins and you put one in a spaceship orbiting Earth for a while, the twin that has been orbiting Earth, when it comes back, will be older, slightly older than the other twin, because the faster you... slightly...
Younger. It's the opposite way.
Sorry.
Because the faster you go, the slower time moves for you, while everything else stays.
That's what I meant, sorry. So time dilation is a thing. So both time and space can be bent and manipulated.
And we did prove that with, prove quote unquote, with using atomic clocks. One, basically they were set identically the same. One was shot into space, orbited the planet a bunch of times, then came back. And the other one just stayed right on the ground, and then they compared them afterwards. And that their theory was the one that was going faster would have experienced less time, and that's exactly what it was. Like, it's a very small amount. Like, I think they said, the twin astronaut that went to space for a year, they said he's like a week younger or something to calculate, like 5 days, or it's not a lot. Like, you'd have to be going a lot faster.
But it's been demonstrated that the faster you go and the more mass that you have, the slower time goes for you. Time actually travels slower closer to the Earth than further away. Anthony Riley once described time, one of the only correct things he'd ever said, as down is the way that time goes more slowly. And he's correct, because down is always towards the center of gravity, and that's also where time
doesn't gravity only affect things with mass though? No. Gravity affects everything. Gravity affects everything because everything has to travel in a path in space-time. Because space-time gets warped, right? Everything has to travel through that. Even light, which is a massless particle / wave, right? But even that light has to travel through that bent space-time, which is what gravity is doing. So gravity affects everything, whether it's got mass or not. Okay, but wait, how is light a particle if it has no mass?
Sorry?
How is light a particle if it has no mass?
It has energy.
I mean, I don't know the answer to that, but I know that we know that light is bent by black holes because we can see it.
The answer to that is in Einstein's equation, E = mc squared. Obviously, you have to extrapolate it out to get when you're taking into account momentum as well. E = mc squared is only for a stationary particle, but if you take E = mc squared for a moving photon of light, you can actually see that the energy equals the mass. So everything that has energy can also have mass, and they've actually demonstrated this recently by generating I think protons from energy. I'll have to look up the exact experiment, but Einstein's theory of energy is mass has been demonstrated to be completely correct because they've literally created matter from energy. So it's all to do with E = mc squared. Energy equals mass times
and the Higgs
speed of light
boson
squared.
too.
Well, yeah, but we don't need to go that far into quantum mechanics. We can answer that question with Einstein's equations.
All right. You want to move to the next point?
Yeah, star trails. Okay,
Sure.
so
Pull up the
right,
thing.
here's the important thing about stars that we see. Okay, all of the stars that we see in the sky with our eyes are pretty damn close to us, like really close to us in the galaxy. And all of those stars are moving around the center of the galaxy with us. So they won't change their position very much. However, they do change their position. So much so that we had to, even though zodiacs are a load of crap, but the stars' positions changed so much that we had to alter the zodiacs to kind of keep up with what nonsense they go on about. Also, there is many almanacs throughout history that sailors have used to document the change in position of stars. In the 3rd century AD, a Greek sailor, described the point of rotation, which is Polaris at the moment, but in the 3rd century he described it as a void of stars that was close to Polaris. So we know that in the 3rd century AD, sailors could look up and see that what we see as the North Star wasn't actually the North Star then. It was slightly away from the point of rotation of all stars. So over the centuries, we don't live for centuries, so we probably won't notice it, but over the centuries and the millennia, the stars absolutely do change. And they've been documented, because if they weren't documented, then sailors that use the stars to navigate would have got lost.
Professor Bell coming in with a fun little fact from the previous conversation, just saying that satellite clocks are adjusted once a week at least, and it said that for a surface clock will tick, holy shit, how many numbers is that? That's 100,000, 100 million, 100 billion. It'll click 1,698,000,000 times for one in deep space, only clicking 1 trillion times.
Right.
So it's just, it's not, even at those speeds, it's not a lot. Anyway, sorry, I didn't mean to, these things go by and they just disappear. Phil Bell was putting in some good information. So.
Sure. Phil Bell is the guy who's put stuff on the moon, by the way. But yeah, so that is why we see the same stars in the sky, is basically because they're all pretty damn close to us in a galactic sense.
My question, one of my other questions was like, why do they make perfect circles and why do they never cross? Because if we're moving millions of miles through space, wouldn't they ever like cross or intersect?
Well, no, because again, they're all the stars we see are moving with us, right? And the North Star, Polaris, is directly in alignment with the axis of rotation. Okay, so
aren't they different distances away though?
Well, yeah, but their distances relative to us stay the same because they're moving through the galaxy with us, right? Say this is the Earth rotating, okay? Polaris is over here, all right? So as Earth's rotating, it's in alignment with the axis of rotation. So to people on Earth, it looks like the stars are all rotating around this point. And the further down you get on the Earth, obviously Polaris will disappear from view, which is why then you get to the equator and you can no longer see Polaris, because it's in alignment with the axis of rotation pretty much directly over the North Pole. And all of the stars that seem to rotate around that point are just traveling through the galaxy with us. They are, in galactic terms, right next door.
Okay. You want to move to the next point then?
Sun, not a ball of gas. What did you mean by that?
All right, so remember, I believe the sun is a light, right? I don't believe in exploding ball of gas. I don't believe it's in outer space. I believe it's on the firmament, and I believe it's very close, not millions of miles away.
I mean, it's been measured to be exactly where it is. You're right, it's not a ball of gas, it's plasma. It's a nearly perfect sphere of, mostly plasma powered by nuclear fusion. We know how far away it is. We can bounce radar off of it. We've sent several probes to it. In fact, the Parker Solar Probe is just completing its 9th orbit, literally within the star's corona. So we can also use spectroscopy to measure and detect the fusion byproducts coming from the star, because according to our model, the star is basically nuclear fusion. with plasma around it. Lots of pressure and heat causes the hydrogen to fuse into helium, right? And that's what powers our star. And we can actually use detectors on Earth to detect the fusion byproducts, because when two hydrogen atoms fuse together, not all of those hydrogen atoms are used up, right? Most of them are to make the helium, but not all of the hydrogen atoms are used up. So there's byproducts that are released, gamma rays, delta rays, alpha rays, all different types of radiation that we can measure, and we can tell that is a byproduct of a fusion reaction. So the fact that we've measured it, the fact that we've sent probes there, the fact that spectroscopy tells us the components of the sun and the mechanism by which it's powered, I mean, yeah, it's definitely not close, because if it was close and inside the firmament, the amount of energy that it imparts onto the Earth, which is about 64 trillion joules per hour, it would keep imparting that. It would never stop imparting that, and we would all be cooked like a easy bake oven.
All right. So what about the sun rays? Why do they come down on different angles then?
That's simply the one time really where the answer is perspective. What you will notice is when you see crepuscular rays, they appear to be coming out from a point. But if you were to say drive along where those crepuscular rays were, you'd notice that they go from being like that to spread out to being like that, because it's simply perspective based on the position that you're looking at it from. The sun could not be directly in those clouds, because half of the world can see the sun at the same time, but half of the world cannot see those clouds. Right? That is simply perspective from your point of view, and that's all it is. You can get anti-crepuscular rays that come up from the ground. Does that mean the sun's underground? No. It's simply perspective based on the sun rays coming towards you parallel, but because you are seeing more than the parallel, they appear to spread out. But if you change your position, you notice that they change with you. Crepuscular rays are not the sun being close.
I agree that if the rays face you, they look like they come down on different directions. But why do these rays? They look like they're just facing the ground. They don't look like they're pointing directly at you. Here, I'll show you a little picture of what I'm talking about.
Which ones?
Like kind of like this. Look. Right. So if they were facing directly at you, like you see how these rays would be, if they pointed toward you, they would look on different directions. I agree that it is based off perspective, but in this video right here, it looks like they're just pointing at the ground.
The video on the right.
Yeah, the top one, right?
Yeah, yeah. Again, if you that video is taken from one position. If you move position, it won't look like that. It's simple.
At what position do you think they would look parallel?
Well, they won't look parallel unless it was just a very small field of view. The larger field of view that you have, the less parallel they're going to look. But it's like train tracks. We know train tracks are parallel, but they don't look parallel as they go off into the distance. They look like they get closer, coming to a point. We know they don't. It's exactly the same thing. Those lights are parallel. They just don't look it because of perspective. You can actually calculate the perspective of alpha equals 2 times the arctan of G over 2r, but it's simple. That is perspective. So yeah, sun not a ball of gas, definitely not small and local, definitely powered by nuclear fusion. We've measured the distance to it, we've sent probes there, and spectroscopy tells us the mechanism by which it's powered and the components that it's made of. Happy with that?
Okay, you want to go to the next point then?
Next point was seasons. Right, so your point was that because the distance to the sun changes by 3 million miles, that should be what causes our seasons. But the thing is, 3 million miles is literally nothing. The difference in radiation and heat that you're getting between those 3 million miles makes practically zero difference. The seasons are caused by energy being spread over a larger area, right? So you've got a ball and a light coming straight at the ball, right? If it's hitting straight on, the parallel ray of light will be heating a smaller area, okay? But if that same parallel light is hitting nearer the top of the ball, the same amount of energy gets spread over a larger distance, meaning that there will be less energy per square mile, which is why the Earth's tilt is what causes the seasons. Because as certain areas get further facing away from the sun, the parallel rays of light have to cover more of a distance. Like Australia at the bottom down here, during the summer, the sun's hitting it like that. But as it's on the other side, during our winter, but their summer, the sun's hitting Australia like that instead of like that. So it's a difference in the amount of energy being imparted over a certain area that causes the seasons. The 3 million miles, literally, the difference in energy received is negligible.
Wouldn't the as you get closer to the heat source, it would increase in the intensity?
Yeah, but it's only 3 million miles out of 93. Well, it goes from like 95 to 92 million miles, right? That 3 million miles compared to the 95 is practically nothing. It really doesn't make that much difference at all. Like, the numbers are negligible. What makes the difference is the amount of the sun's energy being spread over a certain area. The larger area for the same amount of energy means less energy per square meter, which means colder.
Okay.
Okay?
Yeah.
So, do you see how all of the arguments are actually misunderstandings of what the globe says, right? Because everything that you brought up, like Coriolis, gas pressure next to vacuum, magnetic field, gravity should make the planets crash and things like that. It's more not understanding what we say, and than having an argument against it, if that makes sense.
Okay. What about the moon? Is that the next point that you had that you wrote down?
Well, we went up to here. Oh, yeah, eclipses.
Sure. Okay. Let's talk about eclipses.
That was where we went to. What was it you said about eclipses?
Okay, so my claim is that lunar eclipses, right? So the idea with the lunar eclipse is that a shadow cannot glow a color. It's just a lack of light. So it wouldn't make sense that it was glowing red unless there was something else passing over the moon, and if the moon was self-luminous.
Okay, so during a full eclipse, the moon is fully in Earth's shadow. At the same time, a little bit of light from Earth's sunrises and sunsets on the disk of the planet falls on the surface of the moon. Because the light waves are stretched out, they look red.
The light waves are stretched out. Are you claiming because of the Doppler effect?
Well, mostly. But because the light has to, it's coming from through our atmosphere. It's the light from the Earth's sunrises and sunset, which tends to have the red tinge to it. And because the light waves are stretched out, they look red, and that's what we see in that particular point. Well, it's on the eclipses, but the thing is, it's kind of a self-debunk, right? Because what you're showing is completely impossible on a flat Earth. There is no explanation for what's happening there if the Earth is flat, right?
Well, okay, so my claim is that there's a red and black node passing over the moon in the firmament. So these nodes are in the firmament and they're passing over the sun and the moon, right?
We don't see that though.
Well, obviously, they wouldn't be visible because there's no light coming from them. It would be like a red filter passing over the moon.
Yeah, but we never see the red filter.
Yeah, that's right.
The reason why the moon takes a reddish color during totality is a phenomenon called Rayleigh scattering. It's the same mechanism responsible for causing colorful sunrises and sunsets and for the sky to look blue.
So scattering?
Yeah, even though sunlight might look white to human eyes, it's actually composed of different colors. These colors are visible through a prism in the rainbow. Colors towards the red part of the spectrum have longer wavelengths and lower frequencies compared to colors towards the violet part of the spectrum, which have shorter wavelengths and higher frequencies.
So what is scattering the light, though?
The Earth's atmosphere.
But doesn't the Earth's atmosphere scatter blue because of the water?
That's what we see, and it's coming towards us.
The blue scatters, the red dominates.
Yeah, the blue scatters, the red dominates. It's nothing to do with water. It's to do with the amount of light being absorbed by certain parts of the atmosphere. It's literally nothing to do with the water at all.
Okay, so what molecules in our atmosphere would scatter it to make it turn red then?
Everything that's in the atmosphere. all the gas.
But isn't our atmosphere is 99% oxygen, nitrogen? But why would that cause it to turn red?
It's called Rayleigh scattering. As the light comes into an atmosphere, parts of it are absorbed by the wavelengths, and that's what Rayleigh scattering is.
So, so what do you believe is causing the atmosphere to look blue? Then
Rayleigh scattering is the
is it just
the red
like
is,
what
the,
about
the,
the
the blue is
molecules? Because
scattered.
you agree if there was no molecules, it couldn't scatter the light.
Yeah.
Because when light hits water, it scatters blue. You agree that's why the sea is blue, right?
I mean, light doesn't really make the sea blue. It's just the color of the water.
Isn't it because like when the light hits the sea, the light that scatters is more bluish, right? That's why the sea is blue.
No, that's just the color of water. Okay, so right. I've actually written this down for a script for a video. Earth's atmosphere is primarily made up of gas molecules, of oxygen comprising 21% and nitrogen about 71%. In addition, water molecules in the form of droplets, ice crystals, and vapor and particles such as dust, pollutants, and ash can be found in the atmosphere, which is denser closer to Earth and thins out as the altitude increases. When sunlight strikes gas molecules such as nitrogen and oxygen, light of longer wavelengths like red, yellow, and orange easily passes through, while light of shorter wavelengths such as blue and violet is absorbed and then scattered in all directions by the gas molecules. When you look up at the sky during the day, the scattered blue and violet light reaches your eyes. However, the human eye is more receptive to blue frequencies than violet frequencies, so the sky looks blue. Phenomenon is known as Rayleigh scattering.
Can I add to that he was actually not wrong? By the way, I would like to add that it's actually for the same reason you just said, though, because the water absorbs colors in the red part of the light spectrum, so it ends up basically looking blue because it's absorbing the red spectrum and leaving the blue. Ocean's blue because water absorbed colors in the red part of the light spectrum, like a filter. This leaves behind colors in the blue part of the light spectrum for us to see. That's the same reason why the atmosphere takes away the blue and scatters it.
Okay, cool. So you would agree it is the water then?
No,
that's not what's said. But yeah, I like that reach. I'll just back off again.
All the different things in the atmosphere that cause it. Water molecules, ice crystals, vapor, particles such as dust, pollutants, and ash, the oxygen, the nitrogen, and like I said, when sunlight strikes gas molecules such as nitrogen and oxygen, light of longer wavelengths like red, yellow, and orange easily pass through, while light of shorter wavelengths such as blue and violet are absorbed and then scattered in all directions by the gas molecules, the oxygen and the nitrogen mainly.
All right. So the claim is that the atmosphere is turning the water, or not the water, that the light is hitting the atmosphere. It's turning red. It's turning red, and it's making the moon look red.
Yeah, because the blue light has been absorbed by our atmosphere, right? So the light that is gone through the atmosphere from our sunrises and is going towards the moon is red, because that hasn't been absorbed by our atmosphere, which is why at certain points during the eclipse you can see the red on the moon, because that's what's left of the light that's passed through our atmosphere.
Okay, I see. So you're saying it's because it's passing through more atmosphere? Because it usually looks blue.
Yeah, but okay, so the sky looks blue because
sky is catching the blue.
Yeah. The molecules in the air are absorbing the shorter wavelengths and scattering them in all directions, right? And that's why the sky looks blue. Okay, but when we look at an eclipse, the red light that's hitting it is the light that's left over after the blue's been absorbed. So that's why it looks red.
Okay. You don't think that the like sunsets would be caused by like the Doppler effect?
No.
No?
No. The Doppler effect doesn't really come into it. The sun's not moving away from us, so but we know that because it doesn't change angular size. Okay, so that answers red eclipses. It's basically due to the Rayleigh scattering, okay, and the fact that the wavelengths of light have been stretched out because that's all that's left over after the atmosphere has absorbed the blue light. So what hits the moon appears to be red.
Okay. I'll look more.
Yeah, but we would be able to move. We'd be able to test whether or not the sun was moving away or towards us based on redshift, anyways. So
Yeah.
that would be what you're kind of talking about with Doppler effect.
Yeah.
Yeah.
Okay. So what did I write here? I don't know what I wrote there. Something about. Oh yeah. So you were showing pictures of stars and planets taken with an out of focus P900.
Yeah. Hold on. Let me pull it up. There you go.
Yeah, so that's just an out of focus camera taking pictures. If you actually get it in focus,
What's making it look like this though?
Being out of focus.
What about like the little ripples?
Yeah.
Like,
yeah,
you think that's just because it's out of focus?
Yeah,
Wouldn't it be fogged up? Wouldn't it be fogged up though?
No, it's just simply out of focus. The aperture is not correct. If you actually do it correctly.
The flashing of the colors, my understanding was that it's because of gases in the atmosphere passing between you and the object.
But so wouldn't the moon look like this then? If the atmosphere was doing this?
No, not
it does if you look at it through the wrong tool. Hey, you know that one you showed of Saturn? I have a telescope that's behind me on the shelf that I have looked at Saturn in the same size, but far more detail than you have. I could see the rings. I could make out all the different layers that they take, when they show you a picture of Saturn. So if you use the appropriate tools, you do get a better view of certain things.
Don't use a P900.
Okay.
Use
Don't use a P900. It's not a telescope.
What would you recommend using?
One of my friends.
An actual fucking telescope. Start with the word telescope, not camera, and then go forward.
I mean, look at these stars here taken with the correct tools. These are, beautiful actual observations of what stars.
If you go to the Voice of Thunder, he showed in one video how for about $500 or $600, he even lists the equipment you can buy and where to buy it on Amazon, and shows you the pictures he can take of galaxies with $500 or $600 of equipment. It's really, it used to cost you tens of thousands of dollars to do that shit that you can now do for less than you guys are paying for those P900s.
Okay.
So basically, don't use P900 to try and look at the stars.
But it has to be done right. You have to use the right, stuff, and you have to make sure the aperture stays open for a certain amount of time, and you have to use the new telescopes, like the one on my shelf behind me here. That's actually old. That thing's actually 15 years old now. That thing, you basically, I think my camera's coming on. There it is. You basically just point it north, level, and then tell it the time of year, and it uses its database. It doesn't have GPS. It doesn't have a LCD screen or anything. And it tries to pick the two brightest stars in the sky. You manually aim it, and once it does that, it's triangulated. It knows exactly where it is in the globe, and you can just put it to Jupiter, and it'll bring you right to it. And then you've got to use the lenses. It's a telescope. You got to use the different lenses, drop them in, and zoom in, and kind of fine tune it. So and then it'll track it, so you don't lose it. You'll stay with it as the Earth rotates.
Okay.
Or whatever you believe.
Right.
So.
Okay. So the next thing you brought up was Antarctica is an ice wall. No, it's not. I've been there. And there is a bi-yearly race around Antarctica. And they, it's not an ice wall that they're racing around because they don't go like 113,000 miles, which would be the circumference of the ice wall based on known dimensions of Earth. The claim that Antarctica is an ice wall is honestly one of the dumbest, because it's one of the most easily disproven things. You can simply measure the coastline of Antarctica and find that it's not over 100,000 miles. There's several bases that you can go to. I went to McMurdo base. There is holidays you can take to Antarctica. People can go across Antarctica all they want. It doesn't matter. You're going to die if you try to do it, but there's nothing stopping you going to Antarctica and going across it. A lot of countries, you have to ask permission from your country because they need to know that, where you're going to go and die so they can find your body. But, there's no law or anything stopping you from just having a trek across Antarctica. There's people, one of my subscribers who I'm actually going to be talking to in the next couple of weeks lives in Antarctica doing research, quite close to some penguins. So, no, Antarctica is most definitely not an ice wall.
All right. Let me elaborate on my point because I forgot to talk about the maps. Another reason why I believe Antarctica is an ice wall is because if you look at the maps, it looks like the planes are going on curves. It looks, and another thing is that they had to distort the sizes of the continents to basically try to put a flat Earth map on a, try to put a flat Earth map on the globe, and that would mean Antarctica was actually way larger because of the size of Africa.
Map, so.
But continue, sorry.
The only accurate map is a globe. A globe has accurate sizes of continents and countries. No flat map can, because you have to distort what's on a globe to show it on flat. You can't have accurate sizes of countries on a flat map. Now, the azimuthal equidistant map that you're showing there, it is based on what's his name? Dude that came up with that. Alexander. It's
the Mercator projection?
No, it's based on the Gleason map, right? The Gleason map that Alexander Gleason came up with. Now, the interesting thing about the Gleason map, which is what the azimuthal equidistant projection map is that Alexander Gleason created a patent for it. And anyone can go find this, just Google Gleason map patent, and you will find that in that patent, he explains how it is distorted from a globe. So the guy that came up with the map that flat earthers use was literally designed based on a globe according to the person that came up with it. So we know that the azimuthal equidistant projection map is a projection of a globe, and it's projected, it's distorted in the form of distances from north to south are correct, but the further away from the center you get, distances east to west are dramatically increased. So the furthest from the center, east to west, is massively distorted, but close to the center, it's relatively how it actually appears. So, yeah.
Okay. So my question is, why is Africa, or why is Africa 3 times the size of the U.S.?
It's not.
It's not.
Not on a globe.
Okay.
If you look at the actual sizes on a globe, it's really not. Okay, so that was
yeah. We can move to the next point then.
I don't know what I wrote there. You were talking about things being Photoshop.
Yeah. Do you want to go into the conspiracy side?
Well.
Or do you want to just argue proof for the flat Earth? I mean, what's your call?
Well, I'm just trying to make sure I cover all of the points you brought up.
Okay.
Was the next thing you brought up the
do you guys have a time limit, by the way?
I'm good. I can go for probably another hour.
Okay.
Yeah. What was your point about things being photoshopped?
The pictures of Earth.
So one was, one was photoshopped. I mean, probably a lot are, but there's one specific one that was photoshopped, and that's the 2012 Blue Marble. And that was only photoshopped because it was taken by cameras that were too close to Earth to see the entire thing. They wanted a extremely high resolution image, and the only way to do that was to have cameras that were closer, and then stitch them together afterwards. Now what you're showing there is simply a matter of field of view. Let me show you, where is it? So my good friend Tommy Gronville took this photo of a globe. This is the same globe, right? Taken with the same camera, just from different distances away. It's exactly the same as what you are showing in your image. And it's exactly the same answer. It was taken with cameras that were different distances away from the globe.
Wasn't like NASA admit to photoshopping them though?
To one. NASA said admitted to photoshopping one, and that was the 2012 image. I mean, I'm not saying...
Yeah, I don't think they deny it. I don't think it's something they deny. It's just something that...
Most normally, if there's an artist's rendition or Photoshop to them, they normally say...
technically, if you take a panoramic with your phone, it's a composite, because what your phone does is it basically keeps track of the horizon lines using technology, and then it takes a whole bunch of pictures. And then what it does is it takes all those pictures and it just stitches them together along the edges. Well, boom, there's a composite. But did that make it so you weren't there taking a picture of that beautiful lakefront? No, I mean, of course that lakefront is there. But did it become fake because your phone put multiple shots together to compose the image? I mean, that's literally all it is, just stitching them together to make, you know, you take a bunch of different photos and you push them together. And yeah, I think they did have to stitch the clouds and the edges and kind of brush them a little bit to smooth it out, because otherwise you'd have these edges, right?
In the 2012 one, he literally did use a clone stamp, you know, because he wanted to make it look as pretty as possible. That was what it was about.
Sure, he'll talk about it in an interview. Yeah. It's not even like it's a hidden thing.
But you know, the other things about the continents being bigger. I mean, it's simply different cameras.
You want to talk about the rainbow and the firmament?
I mean,
or do you want to skip past that?
Rainbows are, you know, a phenomenon that are explained by our model as well. It's nothing to do with a firmament. It's just, you know, light bending through a medium. You know, if you were to look at a point source of where light was from, it would be, you know, a rainbow with a circle coming outwards. And when you see a rainbow in the sky, the arc, you're just seeing part of the entire circle. It's simple as that. I can look at an oil slick on the floor and it have a rainbow in. That's not from a curved dome.
Mm-hmm. Well, my claim was that you need a refractive medium, and it needs to, you know,
the atmosphere is a refractive medium.
Light takes the shape of the medium it moves through, so it has to be moving through some sort of like dome-like.
Well, the atmosphere is curved. We know the atmosphere is curved because, you know, the Earth is curved, and the atmosphere is also a refractive medium. So, yeah.
So why does it create this dome shape specifically?
Because when you look at like, if you
there's water in the atmosphere, it's all over.
Yeah, but if you look at like an oil slick, you know, it's like a circle from the center outwards. It's the same when you're looking at, you know, there's been rain and there's water droplets in the sky. You're looking at like where a point source of light would be radiating from, and it creates a circle outwards from that point. You know, with the further points that are away from it having the higher wavelength. So it's a circle. A rainbow isn't just an arc; it's an actual circle created because you know, the further away from the point source of light, the longer the wavelength, so it's not absorbed as much, so it appears to be a rainbow.
Okay.
Right.
Okay. You want to move? You want to go to the other part?
Yeah. What was the next bit?
I think you wanted to talk about the ISS footage. Is that what you want to talk about?
Yeah, that was the next one. I think ISS footage. Right. So, what's your issue with this footage?
There looks to be a lot of weird, strange glitches. Like the man fades out in the back. It looks like you can see some green thing that passes over his hand.
So let's talk about the man fading out of the back. That's very deceptive flat Earth editing, because that is actually taken from a composite of you know, a video of clips that NASA had, right? And that is actually a fade between two different scenes. It's not the same scene. If you know. He's zooming in on there in the guy because that nicely hides. If you the equipment to the left, you can see.
You got to admit, it does look like it sucks them into the fucking other.
Yeah,
but it's an awesome just, like. I love the way everything just collapses inwards, like.
Well, he's talking about one on the bottom left with the dude kind of fading away.
I'm talking about the okay, but still, sorry. Yeah. I just looked up and saw the one on the top right, but I thought it was hilarious. My bad.
That's actually a cut between two different scenes. With a fade between them, and you can tell that because in the full video you see the equipment on the left kind of blur from one position to another. So that's not a guy fading out, and it wasn't a live feed. It was actually from a cut of different scenes that NASA put up. So the one on the top right and also the one on the top left, it's just, you know, problems with live feeds. The ISS is traveling at 17,000 miles an hour. Sometimes when I'm video calling my mum, I can get similar effects just talking to her from here. You know, this is just, you know, problems with data being transferred from one point to another. In videos, you have things called P frames and B frames. And when the video is uploaded to the internet or it's done in a live feed, sometimes if there is a frame that is similar to the one before, it will, rather than render a new frame, it will show the same frame again to save memory. Okay? Now, if it does this a few times in a row, but there's been a glitch between the start and the end of that, when it then comes back into using a new pixel for a frame, it looks like there's a weird distortion. And the choppier the feed is, the more likely that it's to be replaced with B and P frames that will give that kind of distortion. Captain Disillusion, actually one of the best YouTubers, he explains it extremely well in his series CD/R. So that's what the distortions are.
Also, another question, like if you see this video right here, I have, she seems to be like she spawned an item in at a complete randomness.
Yeah, that was NASA just like being funny. They were like, oh look at this magic that we're doing. That's, they're not claiming that's live or anything. They're like, literally doing a fancy bit of editing there, and they explain that. So this is just flat earthers that are taking this and going, oh look, NASA fakery. Well, yeah, that literally is NASA fakery, and they said that they were like doing an explanation for kids and trying to make it look magical. The dude on the bottom right there, he's literally doing a magic trick, and he explains later on in the video how he did it. It's not a pocket of gravity, it's him doing a funny magic trick. The top left there, that is not a green screen. You cannot green screen with massive white chunks like that. That is actually from a clip where he is using that grid behind him to show the trajectory and velocity of balls, to use a simple equation to predict the position of something based on its current state. It was an experiment they were doing. It's not green screen. It's something they use quite often to have as a reference in front of things. So yeah, just a bunch of flat earth lies there, really.
Okay. And then I think harnesses, actually, I mean...
Well, there's no harnesses, simple as that. They wear belts sometimes for certain jobs. That's what the guy is doing on the bottom right there. He's wearing a belt. It's pointing up because, they don't have much gravity there. The one on the top right there, he sees the guy is floating off to the side, so he sticks his little finger in his pocket and pulls him in. The one on the bottom left, his shirt's pointing up because there's no gravity pulling it down. Certainly no fucking harness there like he's showing. There's no harnesses. It's as simple as that. There's no evidence that there's harnesses. It's not how harnesses work. And one of the best evidence against harnesses is something called suspension trauma, okay? They will do these videos for hours at a time, okay? Now, if you are in a harness, you can literally only stay in a harness fully suspended for 12, 13 minutes at a time. Otherwise, you get something called suspension trauma, where it cuts off the blood and can cause a lot of damage. This is talked extensively by stunt actors and circus performers. Harnesses are extremely damaging to the human body and cannot be worn for a long period of time. I would advise you just simply Google the phrase suspension trauma, and you will see how none of this can be harnesses.
Okay. All right. Let's go to
underwater was the next one, I think.
Yeah, hold on, let me pull it up real quick.
So why do you say that they're underwater?
So in this footage right here, it looks like he can see something in his visor real quick. And this looks like it could be like a scuba diver due to the black,
It's just the other dude that's out there. There's two of them doing the EVA.
But isn't it supposed to be like white because he's wearing like a white...
It doesn't look black to me
suit
at all. I mean, it's a reflection. You can literally see in the reflection when it's close that the suit is white. It's not black.
Let me get you a better video. Hold on. Or a clip of the picture. One sec. Here it is. Hold on.
And you can, he's partly in shadow there, but you can see part of it that's in the light that has white on it.
You think this is a shadow?
Yeah, he's partly in a shadow. I mean, when the camera actually zooms in, you can see that most of his outfit is actually white.
And right here, these look like little bubbles. It looks like they just could be filming underwater.
Now, if you look at bubbles underwater, you don't just get one and they all go in one direction, okay? If you look at the apparent bubbles in space, they never go in one direction. There's normally just one or two of them. Now, there's a few reasons why you get what appears to be bubbles in space. The outside of the space station, it's in a very harsh environment. Very, very harsh environment. You know, it's in the vacuum of space. So the outside of the space station gets beat up pretty damn bad. And when the astronauts are out there, they can dislodge parts of the the paint and dirt and stuff that's on the outside of the space station, right? Also, their suits are cooled by something called sublimation cooling, right? Sublimation is the process of going straight from a liquid to a gas without going from the solid in between. So imagine it as a really tight mesh on the outside of their suit, and they run water through this, okay? The mesh is literally to vacuum. As the water runs through, it cools and freezes against that mesh. So the water that runs the other side of the ice keeps cool and, you know, keeps their suit cool. However, when they first go out and they're, you know, the system isn't, you know, completely running yet, some of the water can actually escape to space and sublimate. And that's what we see sometimes as the bubbles in space. It's certainly not underwater. An interesting thing about people when they are underwater and wearing a helmet is it causes a very specific refractive condition that actually shrinks the image on the visor. And if you look at images of astronauts when they're doing training underwater and look at their visors, everyone looks really shrunk and tiny because of the mixture of the reflection and the refractive conditions of the water. However, when you look at reflections on astronauts doing EVAs, everything looks relatively normal. So no, there's no bubbles in space, apart from ones that are supposed to be there because of things like sublimation, and a lot of the time it's just dirt and crap coming off the outside and paint, rust, whatever coming off the outside of the International Space Station.
Okay. Moon landing.
Yeah, that
do you
definitely
believe
happened.
moon landing, or you think they faked
I mean, I
it?
don't need to believe it's evidence suggests that it 100% did happen.
I mean, I do have a video of Buzz Aldrin saying that they didn't go to the moon.
No, you don't.
Have you seen the video before?
Yeah. Interesting that Flat Earthers take that one little clip and ignore the rest of the interview where Buzz is specifically talking about his time on the moon. And then the little girl asks him a question. Well, why haven't you been back? Right? And then Buzz answers that they haven't been there because they haven't been back. They haven't. And Buzz knows why. Because of stupid budgetary and political restraints. But that interview is like 20, 25 minutes long. And he talks extensively about the journey to the moon, his time on the moon, what happened afterwards. And the only time he says about not going there is when the girl asks him the question about why haven't they been back. And he says, oh, that's not your question. That's my question. Why, because we haven't been there. I.e., they haven't been back since they went last time in 72. And that's how it was. And I think I know why, says Buzz. And he does know why. Because after the Apollo 17 mission in 72, the budget for NASA and the political oomph of going to the moon practically vanished. That's why. And that's what he's saying. He's not saying they never went to the moon, because he spent that entire interview talking about being on the moon.
What about the idea that they couldn't cross the Van Allen radiation belts? And
of course, I'm going to show you. Right, I may get in trouble for this, right? Because I've got a material here, right? Special material that blocks the majority of the radiation that comes from the Van Allen radiation belts. You ready?
Paper? What is that?
Yeah, it's a bit of paper. This would block the majority of the radiation, mostly alpha waves, that's in the Van Allen radiation belts, right? Seriously, a bit of paper would block most
why
of
did they
it.
say they couldn't cross the Van Allen radiation belts then?
Now, there are areas of the Van Allen radiation belt that have higher levels of radiation, okay? But they are able to track those areas, and it's only being in them for a long period of time that would cause damage. What you are talking about is when they have said recently that they can't go through the Van Allen radiation belts, because technology has changed. Transistors are, and all components are made of bits that are closer together and more susceptible to being damaged by solar radiation. Basically, the change from analog to digital, right? The technology that we have nowadays is more susceptible to solar radiation. If you look at all the laptops and stuff that they've got on the ISS, it's all got little like white and blue spots on the screen because of the damage from solar radiation. And that's what they're talking about. They needed to figure out a way to safely get the new technology that we have through these areas of radiation, because prolonged exposure from the Van Allen radiation belts and other solar energies could have a detrimental effect on the digital technology we have, of parts being smaller and closer together. That's why the majority of the technology on the Mars rovers is stuff from like the late 90s, because that's clunkier and bigger and less susceptible to the dangers of solar radiation. Mars doesn't have a magnetic field like Earth does, so they couldn't use technology that's created in now because it's a lot more susceptible to solar radiation and damaging radiation in space. That's what they're talking about. But for general purposes, a bit of paper will block the majority of the radiation that is in the Van Allen radiation belts.
So why couldn't they have just crossed it? Why couldn't they just use paper again and crossed it then?
Because we've got different technology that is more susceptible to the radiation. So we have to figure out ways to make that safe so that it keeps the astronauts safe as well. And there is some radiation that won't be blocked by paper. Not a lot, but there is some. And that radiation could have a lot more damaging effects on the equipment than it could on the astronauts. The average amount of radiation that the astronauts received during their time in the Van Allen radiation belts was less than 1 rad.
Okay. All right. The Red Bull jump.
What about it?
Do you believe that this was high enough to see curvature?
Possibly. I mean, there was that they weren't looking for curvature up there. Most of the cameras were fisheye. There was nothing leveled.
Okay.
So it's not something that I would ever use as evidence either way, because there's no cameras specifically set up to look for curvature.
All right, that's fine. And we'll just move past that one. Okay, so the Mars, right? So my claim is that they filmed Mars on an island with a red filter, right? And one of the reasons is that I think one person used Google Earth, and they actually found one of the Mars, what do you call it? The NASA
Pictures,
Mars trucks.
So NASA do training in Devon Island because it's the area most similar to what they would find on Mars. So yeah, they go there and they test their equipment. However, there is not one NASA image where they have claimed it's Mars and it's not. Those images that you had up there, the NASA image / Devon Island, none of those are NASA images. I've seen every single one of those. None of those are images from NASA that say they're on Mars. But yes, NASA do use Devon Island to test some of their equipment because there's a bunch of rocks and shit just like on Mars.
Okay. All right. Tesla car.
What about the Tesla car?
God, sorry.
What was your point on the Tesla car?
My claim is that they forgot to add land to the planet behind them.
When?
So I think this is fake.
Yeah, so the one on the left is when they're inside the payload before it's opened.
Yeah.
So when the Tesla went up first, it wasn't just a car that was launched into space. It was inside a housing, right? It was inside a big payload, and then as it got into space, they opened that, and then you could see Earth behind it. It's not they forgot to put Earth in. It's that you can't see through walls.
The land, the Earth on the right.
I mean, they're over an ocean.
Yeah, but this is one side of the Earth. Where's the other?
It's not like 50% of the Earth. They're too close to see a whole 50% of the Earth.
Okay.
They're looking at the Pacific Ocean there. It's as simple as that.
Okay, my next claim is the rockets, they get shot up, then they just go back down.
Yeah, no, they don't. They curve because they don't go straight up. Rockets can... Rockets have to curve to get into orbit, and they're going further away from you. Now, if you look at the image on the bottom right there, it debunks your claim, because you see the gas trail that it's leaving as it goes up and moves away from you. That gas is expanding more and more and more. Even though it looks like that rocket is coming down, right? It's not. It's just moving away from you and up. And you know it's going up because it's going into an area of less and less pressure, which is why that gas is expanding further and further and further. Rockets don't go straight up and then turn to get into orbit. They have to fly east. They go up and then start heading with the rotation of the Earth to go into orbit. So that's why they look like they curve, but they never come back down. Well, the first stage boosters come back down and get caught. But like you see on the bottom right there, the gas is expanding more and more and more, shows that it's actually going up into an area of less and less and less pressure.
Okay. I think that's all my claims. Is there anything we missed?
I don't think so. I think I went over everything. How do you feel about my answers? Because like, this is honestly,
I've heard a lot of them before. Go ahead, sir.
Like everything that you said is something that I've heard before. You know, this is like my 538th Flat Earth debate, right?
Yeah.
And every one of those, I'm pretty versed in debunking because I've heard every one of those claims. And the majority of the claims are, well, there's 50-50 here, right? Half of it is I don't believe, and the other half is misrepresenting the actual heliocentric model, and then saying, well, that misrepresentation, that straw man that I've just come up with is wrong. You'd be right, because the straw mans aren't right. You have to understand the actual physics of the globe to be able to debunk it, and all of the things you said, like the Curie point, the gas pressure next to a vacuum, the spin of the Earth and the Coriolis, and the refraction and everything. Without wanting to sound insulting, it comes down to an ignorance of physics and science in general. And I'm not saying that you're an ignorant person. I'm not meaning that as an insult. I'm just meaning that you're clearly ignorant to a lot of physics, in the same way that I'm ignorant to how to do ballet dancing, you know? I don't know it. I've never studied it. I'm ignorant to how ballet dancers do what they do. In the same way that you are ignorant to a lot of how physics works. And that's not insulting you. That's just saying that you don't know these things because you've maybe never studied them. But if you had the knowledge of the physics behind these things, it would maybe 60% of the questions that you asked you wouldn't need to have, because you'd understand the physics.
Mm-hmm. Do you have anything else? I mean, I guess that's it.
Well, how do you feel about the things I've said? Has anything helped, you realize that what you're saying might be wrong, or did all of it just kind of go in one ear and out the other, and you're not really going to look into anything I've said?
I've heard of these claims before. There's a couple claims that I haven't that I'm probably going to do more research on. But yeah, I think you gave decent answers as well. You know what I mean?
Yeah, I mean, I am extremely happy to. If you have any further questions a bit deeper in the physics, I'm more than happy to talk to you, or even point you in the direction of an expert of things that I may not know. Because I'm not a god. I don't know everything. There's a lot of things that my knowledge isn't as good as a lot of other people, and I have a large community, and a lot of these people are PhD. People that have PhDs. Professor Philip Bell, who has literally sent something to the moon. PhD Tony, who has worked with satellites and gravity and stuff. There's questions that maybe they could answer that I might not be able to. But I hope that I've managed to, at least give you some things to think about.
Yeah. I'm gonna do some more research on one of the topics that you mentioned. This is good. I had a pleasure joining your stream.
I appreciate you coming. I'm just going to quickly look through the super chats I've got and see if there's any questions for you before you go, if that's all right. Let me just quickly check. No, there's not really any questions. It's more just comments on what you've said, but that's fine. Is there anything else you want to talk about? I mean, I know you did bring up some Bible verses and stuff. Did you want to?
Do you want to go through that? I mean, I understand like your platform's not like.
Well,
like you don't really talk about that, so.
My position on God is this, okay? And religion in general. Religion I hate, right? But if we're talking about God, I don't have a belief in God, but I could never say that God doesn't exist, because that's not something you can test for. It's kind of an unfalsifiable position. I think that science, it shows us that the Big Bang is a thing, but who knows what caused the Big Bang? Could it have been a higher being? Could it have been a god? Could the Big Bang have contained all the, the pre-planned information of the universe because of what a higher being did? I don't know. I could never claim that, but I do not think that the universe, the way that we know it, needs a deity to function.
Okay. I mean, if Christianity was true, would you be a Christian?
I don't think I'd be a Christian. I have an big issue with organized religion. If God
not
was
organized, not organized, like just,
right. Well, okay, so here's the thing, right? If God was real, we would be fighting, and I'd throw the first punch.
But why is that?
Because if God's real, then he's a psychopath.
What do you mean?
Well, let's look at the Bible, for instance. How many people did Satan kill in the Bible?
Well, the thing is, right, God does punish evil people. Do you disagree with punishing evil?
God wiped out the entire planet.
Yeah, because what usually happens is that the evil people eventually kill all the good people, and then it's just evil only.
Okay, so let's get a bit personal for a sec. My little sister was the youngest person in Europe to ever be diagnosed with multiple sclerosis. She is the least evil person you could ever imagine. Why did that happen?
Why did that happen? Well, there's sin in the world, right? And sin entails that there's going to be bad things that happen to good people. Like we're not granted eternal life here. It's in the afterlife.
God,
you know what I mean?
But God is he's omnipresent. He controls everything. Why did he give one of the nicest people in the world a deadly disease?
Why is
there a fly, right, that has evolved specifically to lay its eggs in the eyes of children?
Why is there a fly that evolves? I mean, I don't know. Like I said, there's evil in the world. That doesn't mean that. This is just a test.
God is punishing good people. Why would I worship someone that allows that evil to happen? God.
Well, do you believe
if God created the universe and everything in it, that means that God also created evil.
Do you believe suffering is a bad thing?
I'm in chronic pain every day of my life, and it fucking sucks.
Okay. So, but do you necessarily think suffering is bad?
Yeah, suffering sucks. No one should have to suffer.
Well, the thing is, right, so if there was no suffering, how would people change? How would people learn to hate evil?
Well, I don't need a God to give me a moral compass. I just know what's good and not.
Mm-hmm. But the thing is,
what's
going to cause people to change?
What's going to cause people to change is them being taught what is right and wrong.
Yeah, but the thing is, how are they going to learn to hate what's evil if they don't suffer? Like, because I'll give you. I know you probably don't.
Why do you have to hate things? And evil is just really a state of mind. What some people might see as evil, others might not see as evil. There's no reason why an all-powerful, all-knowing God would punish people that have not done anything wrong. My uncle, he's got Down syndrome, right? And when he was born, they said, oh, he won't live past 4 or 5. He's about to have his 60th birthday. But he's had to live his life, his struggle and suffering because he's got Down syndrome and things weren't easy for him. Where was the sin there? Why he was born with an extra chromosome? Like what did he do to deserve that? And he is you know, by his very nature, one of the nicest people in the world. You know, most Down syndrome people are just, you know, happy, friendly people. You know, why did he deserve to be punished from birth? You know, if God is real, he is a horrific, you know, petty, psychopathic, evil, sadistic, horrible thing that does not deserve to be worshipped. I don't want to worship someone who's gonna, you know, whip me if I do wrong and punish me if I do wrong. I don't want to worship that kind of person. That's not anything I would ever choose to worship.
Whoa. Your relationship is too tight, okay? Sometimes I say naughty things to my wife just to get this kind of action, okay? So I had to. Come on, have some fun. Sorry, I didn't mean to take your thunder.
But if
keep going.
Yeah, I want to hear your point.
I was listening. My apologies.
Yeah, go ahead.
Right, that's how I feel. If God is real, if the monolithic Christian, you know, Judaic Muslim God is real, then he is a horrific, horrible being that, in my opinion, should not be worshipped under any circumstances.
Okay, so the first thing I have to say is that, like, we're not here to, you know, live a joyous, happy life. We're here to understand what evil is, right? Because this is just a vetting process, right? So we're going to be vetted who really likes doing evil, who really likes doing good. And the people that love evil are going to, you know, get punished. The people that hate evil are going to spend eternity with him, right? So that's why we're here. We're not, suffering is good because it leads to repentance. It causes you to change your mind.
I don't want to go to heaven. Heaven honestly sounds like, you know, like a boring place. I don't want to. I honestly would not want to spend eternity with a psychopathic, petty, you know, horrible, nasty God that because he didn't like what was happening, decided to kill all of humanity and start again. You know, if we are looking at God v Satan, Satan's the good guy. It's as simple as that. How many deaths did God cause in the Bible versus how many deaths did Satan cause in the Bible? Satan caused 0 deaths in the Bible.
God gives life, he can take it away.
Everything. Why does he have the right to take my life away? What gives him that right?
Well, he created you. He's the arbiter.
No, he didn't. The universe created me. Why does he have the right to... If he's given me my life, he does not have the right to then take that life away from me. It's now my life.
Why not?
He does not have the right to make me suffer, because that's just literally being evil. You know, we should fear this God because he can just take away our life if he wants. Fuck that. I am not worshipping that God. Even if he is real, I refuse to worship a horrible...
I want to elaborate on one thing, right? So the thing is, like, the reason I'm a Christian it's because I hated evil, right? And once you hate evil, it causes you to change your mind, and then you start to do what's good and you follow his laws, right? And the reason why this world sucks because people like what's evil. You know what I mean?
See, I disagree with that philosophy in general, because you've got to see, you know, have evil to see what's wrong, but no, not necessarily. You just get taught what's right. I'm a father of 2, and I don't have to use the terms evil and good to give my children a moral compass. They just understand that, you know, there's good things and there's bad things. It's nothing to do with, you know, it's instilling a sense of goodness into them. You don't need a God for a moral compass.
Well, the idea behind this is that, like, we're basically, we live in a world of lies, right? We're being taught lies, and the thing is, the reason why you do evil is because you believe in the wrong thing. But what causes you to change your mind is to hate what's evil, right? Because the thing is, the reason why your life is bad is because it's because you believe in the wrong things. You believe in the wrong things, you do the wrong things. You know what I mean? So when you suffer, it causes you to change your mind and to do eventually the right things, and you just start hating evil, and then you're prepared for eternity, because God only wants people that will hate what's evil to spend eternity with him, right? But if you like what's evil...
Wait, God doesn't want hate at all, according to the Bible.
I'm sorry, what?
God doesn't want hate at all, according to the Bible.
Yeah, he does. He wants us to hate what's evil.
It doesn't say that in the Bible, though.
Yeah, I'll show you. God actually does hate evil people. Let me show you, look.
But God's supposed to love all.
No, he hates evil people.
But he created them. So he hates something that
no, he created. Okay, so he created you good, but the lies of this world, you know, tricked you into doing evil. Well, you have your free will.
He created the world, though. Well, apparently I don't have my free will because you just said God can take away my life when he wants.
Yeah, you have free will. You can do whatever you want, right? But the thing is, you're going to get judged after you die, just like any other judge. Like if a judge does something...
I don't need God as a moral compass to tell me what's right, though. I don't need to have
it's built in
evil. I don't think it is. That's just an assumption.
Okay, well, yeah, then we just disagree. But regardless, in my worldview, you have a moral compass built into you know right from wrong. But if you love evil, you go to hell. If you hate evil, you go to heaven. That's it. This is just a huge vetting process. You know what I mean? So God is gonna choose. Okay, do you like evil? Okay, then you're gonna get judged. If you hate evil, you're gonna go to heaven, and you spend eternity with him, because evil is what's causing all this
God
chaos.
God is the arbiter of what is evil and what isn't. So he alone gets to decide what is right and wrong.
Exactly. Yeah.
I disagree with that because he's obviously a psychopath and he should not have that responsibility.
Okay. Well, I mean, I think Craig. I think the reason why you think that is because you're evil yourself, right? And you don't want to be subject to his laws.
I'm definitely 100% not evil. I am a good person. I want nothing but the best for the world. I want the world to be.
God damn it! This man is Cupid.
You know, I have done nothing but instill good in my children. I try to spread truth throughout the world.
Okay, I have a better question for you, Craig. What is okay? If let's say you were God, right? I put you in God's shoes. What laws would you change? Like, what shouldn't be a sin?
Smoking cannabis should be legal.
Okay, yeah, so it is here. So what's your problem?
Hold on.
I live in Scotland. It's not.
Let me ask him. So wait, what are the top 3 things that shouldn't be a sin?
I don't really say that things are a sin.
Like, you would be like, hey, why would God send someone to hell for this? Like, this shouldn't be a sin. Yeah, like, what are the top 3 things?
Trying to think of the movie Slevin. What are the 7 deadly sins? I can't remember any of them. My mind's gone blank.
That's not a 7 anything. Like,
no, I know anything. Okay.
Yeah. What shouldn't be a sin?
Let's take gluttony for example. Oh man! All right?
You know what? I'm gonna back out because I was about to say some crazy shit. You guys talk.
No, you can say whatever. I don't care.
No, you have no idea. Trust me.
Oh, okay.
Like,
I mean, if it's involved in sex, just say it. Like I.
Oh no, that's not a problem.
All right.
Anyway,
so homosexuality. Homosexuality should definitely not be a sin.
Okay, so let's talk about that.
Love is love.
It has to do with lust, right? So all feeling of lust.
No, it has to do with love, not lust.
Well, the thing is, homosexuality, I wouldn't consider that as love because the only reason why people
you would be very wrong. You'd be very wrong because I know lots of homosexual people, homosexual couples, and they definitely love each other. It's not lust, it's pure love.
Because you're a sinner, Craig.
Okay, so the reason why I disagree with this is because the homosexual just feels rejected by their own sex. They're looking for validation.
No, incorrect. Most of the gay people I know have never had an interest in the opposite sex, so they've never had the chance to be rejected by the opposite sex.
It's not that they got rejected. It's not that they got rejected. It's that they don't have a fear. They don't have a fear of being rejected because they are not attracted to the opposite sex. It's not fear. What I'm saying is it has nothing to do with fear. It has to do with the belief system, right? So I'll give you an example. Like, why do homosexuals hang out with like a male homosexual? Why do they hang out with women? It's because they feel rejected by the men. It's just they're just seeking validation. You know what I mean?
No, it's not. It's usually because homosexual men, have some of the same values as a lot of women in modern society. Fashion.
Well, they're trying to act like
etc.
women to appeal to the men.
No, they're not trying to act like women. They act like they act because of the particular hormones and stuff in their body. They're not choosing to act a particular way. They're not choosing to be gay.
You realize that,
just
like,
gay.
You realize that how they act is not actually a definable thing. Because I have known plenty of gay people, men, women, but I have known plenty of gay men that you would not know that they are gay. There's no lisp in their talk.
Closeted.
If you think, they're not closeted. You can think they're closeted. They're just comfortable, and they chop wood and fucking make fires and go camping. Your idea of what a homosexual is flawed just from the base. And I'm going to be honest with you right now. This is a topic that will fucking... I'm just going to fucking back out and let you guys... Yeah, because I'm about to hit mute because I'm about to fucking murder somebody here. So because everything you fucking believe in is a fucking joke at this point when you start talking about homosexuals. You don't believe that people have any ability to form any sort of other brain structure other than what some sort of fucking jerk off in the sky says they can.
Can I elaborate?
No, can I elaborate? Your book is a fucking joke because it both says that people have the free will and they're made by God, plus they don't get to fucking make choices because there's goddamn, the Lord has a plan for you. It works when you don't like it, and when you say, oh, why did that happen? Oh, it's part of his fucking plan. Oh, why did this happen? Because the Lord fucking favors you. You give an excuse when something shitty happens. You give an excuse for it when something good happens. The reality is we're all just jerking off into the fucking dust and you're floating like everybody else. And I am fine with you believing whatever the fuck you want to believe. But the second you start telling people that they feel any sort of fucking way when you're not that fucking human being, because I'm going to tell you right now, if you think for a second that when an actual heterosexual male wakes up in the morning that they have to make any sort of choice over whether or not they're gay or not, then you've got to look in the mirror and realize that you got some issues to deal with because that is not universal, sir. I know when I get up in the morning exactly what I'm interested in because it has nothing to do with being accepted or not. And just so you know, my brother's fucking gay. And one time he said to me, he said, do you think that anybody would ever fucking choose to be gay? If I could take a pill that would make me straight so that people would accept me, I would. But the reality is that you're born the way you're born and you cannot change who you're attracted to. And if you do choose to be attracted to females and not men, then that is something you need to deal with because that is not universal, sir.
Okay, you mind if I elaborate on one?
You can elaborate, but I'm pretty much done with you now.
Well, don't leave. I just want to address one of your points. Okay, so my claim is that this is not something that's foreign to me. I felt the same feeling, but it was with women. I was lusting after women because I was looking for their validation. But the truth is that they're already accepting
I do it to my wife all the time.
Sorry.
No, you go ahead. It was your turn. My apologies.
Okay, so the idea is that that people are naturally accepting of you, and when you think people don't accept you, it causes people to reject you because you act different around them. You know what I mean? And the thing is, I was doing the same thing, but with women. I was lusting after women. It's because I felt rejected by them, and it's the same exact situation with the homosexual. But you can overcome it because God created you a certain way to act, and when you deviate from that, it ruins your life. You know what I mean?
How has it ruined my brother's life, for instance?
Well, let me explain. It's like the LGBT community. Why do they? Why are they always looking for people to accepting? They're causing themselves to get rejected by people. It's because they're changing the way they act.
They're looking for acceptance because they've had the persecution for so many fucking years for something they literally have no control over. All right?
They will literally throw you off of buildings in some fucking countries if you're gay.
Here's the thing, right? If God is making people as they are, then God is the one making people gay because they are born that way.
It's a false belief.
No, it's not a belief. It's not a belief. It's not a belief at all.
It's the fact that they don't feel accepted.
No, it's nothing to do with that.
My brother has more friends than I've ever fucking had in my entire life.
Hold on.
He's accepted.
It's being gay is not a belief or something you choose because you weren't accepted. Being gay is something you are because you are born that way, right? Do you know I've got a 12-year-old son, okay? Do you know what I would say to him if he came up to me and he went, "Dad, I'm gay"? Do you know what I'd say? I'd say, "Hi, gay, I'm Dad."
I would ask him. I was like, "Do you feel accepted by men?" And he would say no.
No, he wouldn't. He doesn't think like that.
Why?
Because every gay person that I ask them the same exact thing. Or a lesbian. I asked a lesbian, "Do you feel accepted by women?" They always say no to me. Why do they say no? It's because that's the belief. You can fix it.
right? But I know
are these other people you're talking to religious? Like I don't
no, they're atheists. They're atheists, and I talk to hundreds of them, and they always say the same exact thing to me. And then when I tell them that they're accepted,
it sounds like
they
there
come
might
out
be a
of
bit
it.
of
Stop being
in
gay.
the closet acting here. I mean, are you annoyed because you have gay feelings?
What, me?
That's what it sounds.
Yeah.
Well,
no, I already told you. I used to lust after women, and now that I feel accepted, I don't lust anymore. You know.
I mean, that's a you thing, really. But
I mean, it's like I lust after my wife all the time just because she's beautiful and I like to, be around her and stuff.
Lusting is a problem because it causes you to act differently around them, and it causes you to get rejected. That's a problem.
Yeah, I mean,
you don't want your wife to be rejected.
When I met my wife, I fell deeply in love.
But now we're getting into the basics of man and women marital common problems. Like,
yeah, but she's already attracted to you. You don't have to do anything.
I agree. I've been doing great lately.
Okay, but I'm saying the lust is causing rejection.
Excuse me, I've been married for like 15 years. Trust me, you have to keep doing stuff.
No, you don't. She already likes you.
I think what we're going to do is we're going to end that conversation there because that can get quite heated.
Yeah, let's just get off this one. This is creating a lot of
anger. It's a conversation that I wouldn't. It's a conversation I wouldn't mind continuing on another channel like Modern Day Debates.
Okay. Do you want to talk about anything else, or are we going to end the discussion here?
I think that's about everything for today. You've made what your positions are quite clear. Flat Earth wise, I sincerely hope that I've given you things to think about. Please do research the things that I've said. Rewatch the debate, and if there's anything that you want more information on, I'll be happy to give it to you. But please realize that homosexuality isn't a choice or anything to do with being rejected. It's just how you're born. It's as simple as that.
I've cured homosexuals.
No, you haven't. Anyway, so
you've closeted some homosexuals, is what you've done, sir.
No, I fixed it.
Yeah, you stuffed them back in that closet and fucking locked the
door. Slave of Christ.
Yes, I did enjoy the conversation.
Please, you're in the closet there quite hard. See you later.
Yeah. Anyways, we're not. Yeah, it's all good, man. It's whatever. Yeah.
All right. So that was Slave of Christ. Exactly what we would expect a religious nutbar to be, right?
Yeah, it was. Wow, I apparently expanded this window wrong. What the hell happened over here?
No.
I see. He left, and now I'm like in multiple windows.
Yes. Let me sort that out.
Oh man, I'm sorry. He fucking set me. I literally sat over here with the mute button pushed for a while and just kind of listened to him talk, and I just get so angry. Like, I grew up with my brother. I promise you, he's got more male and like I'm a very like introverted style person when it comes to actual I'm just not. He's got more friends than I've ever had. I promise you, he's very accepted. I think a lot of what I heard there was a little bit crazy, but hey, I don't think that you and I thought that the second that conversation started, we were about to change minds.
No. If there is evil in the world, it's thinking the way that he does.
That's not right, but yeah, okay.
No. Yeah. I mean, if God is all loving, then he would accept anyone, no matter your sexual orientation. It honestly blows my mind when they're like that. All right, anyway, I'm going to read
I don't know. I just never understood
stuff.
it. I've never understood it. I don't have a problem. I even got like, just so everybody knows, full disclosure, I am the most heterosexual person, but you know what? My brother's like, you want to go to the bar? And I'm like, sure. And he's like, we're going to like the gayest bar you've
so
ever
much more
seen.
Fun.
Oh no, he's like, we're gonna, just because he doesn't normally go there. Like, my brother's this, like, okay, so here's where I was talking about when I said the whole thing about not knowing they're gay. So one time we're sitting on the deck. My brother is an out of the closet gay at this point. He's in college. I'm in high school still. My friends, so we're 16, 17 years old. My friends are on the deck chatting it up with my brother for like an hour straight. And I'm sitting there drinking, having beers with everybody, chatting it too. He's like, I gotta go, guys. I'll see you in a bit. He leaves. And my friends immediately, it's the funniest thing I still remember to this day. They lean in and they go, "Are you sure he's gay?" And I went like this. My answer straight serious is I'm like, I'm not the fucking one that says I'm gay. He is. Ask him. like this isn't like a secret I've ran around and told people. He's the one that says he is. Because they were like, "Are you sure he's gay?" Because they were expecting lisps and certain types of behavior, and here's just some dude having a beer with them. So,
Yeah.
so that's why when I hear people talk about, that's what triggered me, is when I hear them talking about how people are supposed to behave, because I've seen, and my brother's literally said to me, like, he said, I don't know why some of them dress like that and be that way. He's like, I don't know. He said, but we do us, right? But I went to that bar with them, and like, there was people dancing on stage and all that stuff, but I was like front and center, right up there in the front. Woo! I don't give a fuck.
Gay bars are so much fun.
I was just there for a good time. Sorry, go ahead.
Right. Let's end the poll. Is there a God? 871 votes. 20% said yes and 80% said no. So, yeah. I purposely didn't give a I don't know option because I wanted to see if there was a black and white choice what people would put. And most people say no, there isn't a God. If there is a God and you're watching, God, this is to you. I want to fight you. 1v1 me, bro.
Fucking 1v1 me, bro. We could do that as a skit. We could do a God versus fucking FTFE. I'll dress up in white.
Yeah, totally.
Oh man.
This channel is LGBTQIA friendly. I am an ally, and I always will be. Right,
to the one person I told to eat my asshole, I apologize.
Junk Shop Library.
I'm sorry. It was me. I felt attacked.
Junk Shop Library, new member, thank you very much. Tim Tully, $5. Starting with the Black Swan, will somebody tell these guys the meaning of debunked, please? Yeah, if you want to see a thorough debunking of the Black Swan, check out Flerfs. Philosopher King Gaming for $5 says, if gravity is real, all the planes would crash into each other. All the planets would crash into each other. That may be the dumbest thing a flat earther has ever said on this channel. I don't know. Anthony Riley said that Alaska wasn't part of America. There was that.
It wasn't part of. I missed the. If you were talking to me, I missed it. I was reading the chat. I wasn't. I'm sorry.
No, I'm just saying that Riley said that Alaska isn't part of the USA.
It wasn't originally, but it has been for as long as I've existed.
Beanie Beeman for $2 says, everything you just said is wrong. Yeah, his 10-minute intro was like all Flerf debunked things in a nice, easy package. 3-1 for $5 says, slave to fiction. Is this your first day flirfing? You regurgitate thoroughly debunked cult talking points. Really good. Yes, he does. Brad Dubay, Eric Dubay's smart cousin. $5, let those dead horse beating continue. If the Flerf's greatest hits. Addison for $5 says, if the Earth is flat as you claim, why is all navigation based on a globe? Should have asked him that. QED $5 says, why does your guest find these old flat Earth memes convincing in 2021? Because flat Earthers are fucking idiots. Ding. Oizen for $2 says, po. No, genuine idiot. D. Bronowski for $5 says, collect them all, poker claim. Yeah, Flat Earth Bingo would have been gotten in the first 5 minutes, 100%. Steve6464 for $5 says, you just vomited up what every Flat Earther has said before. No new stuff here, there never is. Rachel O'Daniels for $5 Australian says, gotta run, have a blast, wish I could stick around. Wish me luck, especially since there is no God to pray to. Good luck in whatever you're doing, Rachel. You're one of the most awesome supporters of the channel. Takas Janos for 2,048 HUFs. I got a huff 2,048 times. What's HUF, Brainy?
HUF capitals?
Yeah, that's the currency. 2,048 HUF.
Oh, Huff?
Yeah.
Huffington Posts. I don't know.
One of the ugliest Bible verses, Genesis 19:8. Behold, now I have 2 daughters which have not known man. Let me, I pray you, bring them out unto you, and do ye to them as is good in your. Yeah, did they just like whore out his daughters? Lovely.
Hungarian forints.
Thank you. 2,048 of them. I appreciate that. Sleepy Dan for $2 says, it's not a vacuum if there's a whole planet in it. Yeah. Any flat earther that comes and says gas pressure next to a vacuum, I'm just like, that's not our claim. Aaron Reese, $2 says, there is no force in space to pull the gas out. That's right, that's not how a vacuum works. The only force is Earth pulling it in. Synthetic, $2 says, the Apple's mass needs more force to accelerate. Absolutely. To accelerate the same speed as the feather, it requires more force, which is why it hits. Rumple Girlskin, $9.99, and he retracted his message. I'm not sure why that is. Then another one for $4.99 says, why is it necessary to disprove a spherical Earth? A spherical Earth disproved a flat Earth many years ago. What is the motivation? They want to be special. That's it. Flat Earthers want to be special. And they are, just not that kind of special. More back of the bus licking the windows kind of special. Eon Dust for $5 says, as nice as this guy is, he's not. He really is just parroting, repeating the same old things from other Flerfs. Yep. Johnny Marr, £2. He claimed planets were angels, did he? I fucking missed that. Robeeb, $10, says, if God knew everything would be like this, then God is inherently evil. God created the rules and set up a system that would directly result in his creation needing punishment. He knew it would be. Yeah. That's why I say, if there's a God, he's a fucking dick. 1v1 me, bro. Alison for $2 Australian. So God made suffering because he made evil. Logic. Aaron Reese, $5, says, Craig, I've been out of work on disability for over a year now, and you were one of my inspirations to begin working on my own channel. Thank you. That warms my robot heart. My NASA implanted organs, thank you for that. Brad Dubay for $2, humans made a narcissistic god. Oops. Adam Albiba for 15, I'm not sure what that is, but thank you. I'd sure choose hell, where all the awesome people are. Oh, and by the way, they probably made an underground Singapore out of it by now anyway. Yeah, I reckon hell be where all the good parties are. Holy Smalls, $5, says, I love it when FTFE preaches about God. Preach it, brother, fight, and bless you. Preach. Free Ron, $5, God promised to rid the world of wicked people. They're still here. Odin promised to rid the world of frost giants. I don't see any frost giants, praise Odin. He's got a good fucking point, right?
Yes, he does. But I have to admit something. Somebody asked me a Rick and Morty question, and I'm saying it in the chat right now. I've never watched a Rick and Morty yet.
I'm just going to remove
not even one.
It's cool.
I've just only seen the part where the clip where they
How have you not watched Rick and Morty?
Like,
what the fuck's
it's gonna
wrong
be like
with
20
you?
minutes. In and out, 20 minutes, in and out. And then it's like 3 weeks later and they've like conquered the aliens and they just start crying in the spaceship. It was the funniest thing I'd ever seen in my life. So don't get me wrong, I gotta watch it.
You need to get as stoned as you possibly can and just binge all of them, okay?
It looked funny.
Especially season 2. Season 2 was amazing. Holy Smalls, Brad Dubay for $10 says, Xanos Karate for $2. If I were God, I'd say owning people is evil. Yes, it is. Brad Dubay, $10. So God judges you on how you use your free will, and if it's in compliance with his plan, and leaves behind a book full of instructions that forces one to fail. Yeah, there is no free will according to God. Holy Smalls, $5 says, here's a $5. Calm down, Beaver. No, Beaver needed to go off then. He did well. Holy Smalls for $5.
I don't know, was that near the end? Is that at the end here?
Yeah.
Sorry.
I'm clipping that and putting it up as a short. Don't make a Beaver angry. Holy Smalls for $5 says, this guy worships such a weak God. Why not follow what Christ said? Love. Try loving your neighbor for once. You give the religious a bad name. Yeah, I know a lot of religious people and they aren't assholes like that guy. In fact, I know a religious gay guy. So, Eon Dusk, $5 Australian. Listen, sweetie, you know nothing about this. Take it from someone who's part of the LGBTQIA community. Pert for $5 Australian says, oh, I moved it. Monk who spent life teaching compassion will be tortured for not believing Jesus, yet Jedamar, a serial killer, will be in paradise forever, accepting Jesus in prison. Yeah, you can do what the fuck you want and just get forgiven, right? Mary Keane for 15, not sure what they are, but thank you. Ask the Ignorance King if he can choose to lust after men. The Sun Express, $10 says, the fact that hormones were wrongly used to treat homosexuality is a clear indicator that there are psychological differences. Either support LGBTQIA or leave them alone. Yeah, absolutely. Eon Dust, $5 Australian says, and as it turns out, he's not that nice after all. No, homophobe. Mary Kane for 15 says, Brainy, this is called I'm more man than you'll ever be and more woman than you'll ever have. Yeah, Brainy was very good at saying that. They're complimenting you for your defending gay people against the horrific.
I just didn't quite get it. I get it now. Yeah, no, it's good. I listen. It'll always be my defense point. I'll always be with them. So.
Eon Dust, $5 Australian says, hey, as long as there's drag shows in hell, I'm more than happy to go there. Yeah, hell will have the good weed. Philosopher King Gamer, $5 says, slave cured homosexuals. Homosexuals, we just pretended to be pilots. Told him what he wanted to hear, so he'd fuck off. Yeah. the homosexual's probably like, yeah, I'm not gay anymore. Will you just fucking leave me alone? Ozin for $2 says, God can't cause a paper cut on me right now. No, but I can. There we go. Oh shit, I just blew up Brainy's head. Draco Fire for 500 yen.
I didn't mean to like suck the wind out of his sails. Sorry, continue.
500 Japanese yen from Draco Fire. Missed the stream due to wisdom teeth removal. From what I'm hearing right now, it'd be worth the rewatch. That's how I know how fucking young you are, having your wisdom teeth out, Jaco. Eon Dust, $5 Australian, says, the Flerf may have been nasty, but at least I got to look at a sexy beaver. Give me a sexy beaver dance. I can make him dance on command. Fucking brilliant. Garrett Rody, $10, says, I don't get how people don't understand field of view on a sphere. I have a simple graphic which demonstrates visually exactly why this happens. Want me to send it to you, Craig? Yes, please. fighttheflaterearth@gmail.com. And last super chat is Matt Bryce, $2. Thank you both for shooting him down. No worries. Always an ally. Well, that was fucking fun, wasn't it?
Sorry, that was a fruit fly.
Gary Wabenga says, what's the difference between a homophobe and the racist who uses the N-word on your show? Well, I wouldn't know because there isn't a racist on my show. Using
big racist writer. You got me.
Let me just say, using the N-word doesn't make you a racist. Using it in a derogatory way towards a person of color makes you a racist. Brainy, did you do that?
No, I did not. I also don't. No. I don't think I've used it since. It was an accident.
Never used it before, I imagine. So, yeah.
I don't know.
Gary?
I was just having a good time, so give a guy a chance to get some loot, but I didn't didn't say give a guy a chance. I said something else.
Listening to that rap music. But, Gary,
it's a bit of a shit excuse, but it's what happened. I mean, it was like 3 in the morning, and my brain chose the wrong fucking word. What do you do? Like, fuck, I don't know.
Holy Smalls, $5 says, I still don't understand why people care about what other people do with their sex organs. Is it your poo shoot they are tagging? No? Then it doesn't matter. Absolutely. Right.
I'm going to tell you right now, that guy doesn't have nearly as much fun with the women he's lusting after if he feels that way about his bumhole. I'm just kidding. I'm joking. Hey, what you do when you close the curtains on first class or wherever you're alone is what you do. Anyways, I saw a blink on the screen here. What's going on? Did I kill FTFE?
Lord Luminous Pooh for 348 says, this guy should never get your platform ever again. No, you're absolutely right. He definitely shouldn't get my platform ever again. But that's going to be it for tonight. Brainy, what are we doing next?
What are we doing next? Should we be... Were we supposed to do something next? You had said something about an after show. Team
is streaming, so we could go and invade him.
We could always go raid him for a few minutes. Yeah. If you've got an invite, if he knows we're available, we could do that.
Oh,
that would be...
he says I.
I see. You mean just go raid his channel? So yeah, that's a good idea.
All right, everyone, go over to Team Skeptic's channel.
Link
Brainy
it.
Beaver.
Somebody link him.
Brainy Beaver is most awesome. He will have more content coming now that summer's kind of done. He doesn't have to keep putting shit in people's houses. He does excellent content, so please do subscribe to him. The link to his channel is in the description. Thank you, everybody, for watching. It's been an amazing stream. Remember that stupidity is not a right. Fight the flat earth. Head on over to Team's channel, where we're going to go over there now.
Somebody link it.
Link Team's channel in the chat, please. One of my mods. Good night, all.